Agartala and the Department of Electrical Engineering, Tripura Institute of Technology. I, Dipraditi Raivarman, on behalf of this institution, welcome you all. I would like to welcome everyone, those who have joined us physically and also those who have joined us in online mode. Before starting the program, I would like to welcome our dignitaries on the dais. We are glad and thankful to Engineer Debashish Sarkar sir, Dr. Priyanath Das sir, Engineer C. Devnath sir, Engineer Mahananda Devnath sir, and Dr. Shubhadip Bhattacharjee sir to please come on the dais and take your seats. Thank you, gentlemen. Engineer Debashish Sarkar sir is currently busy in a meeting, so he would be joining us shortly. So we are going to start our program by distribution of memento. I would request Engineer C. Devnath sir to hand over the memento to Engineer Debashish Sarkar sir, though he is not here with us. So we would proceed with Engineer Mahananda Debbarma sir. And Dr. Ithoraj Sen sir. Thank you. Today, we are glad to have with us Dr. Hemanto Thakare, President IEI, Engineer Shishir Kumar Banerjee, past President IEI, Professor Sudhir Kumar Kalla, Chairman, Electrical Engineering Division Board, IEI, Engineer Mahananda Debbarma, Director General, Tripura Renewable Energy Development Agency, Engineer Debashish Sarkar, Managing Director, Tripura State Electricity Corporation Limited, Agartala, Dr. Ranjan Kumar Behra, SMIEE, USA, Professor, Department of Electrical Engineering, IIT Patna, Dr. Oshim Dotto, MIEE, USA, Associate Professor, Department of Electrical Engineering, Tezpur University. We also have with us Dr. Ithoraj Sen, FIE, Principal, Women's Polytechnic, on Engineer C. Devnath, Chairman, IEI Tripura State Center, Dr. Priyanath Das, Chairman, Electrical Engineering Division, IEI Tripura State Center, Engineer Subhash Chaudhary, Advisor, Electrical Engineering Division, IEI Tripura State Center. We also have with us Dr. Shubhadip Bhattacharjee, Honorary Secretary, IEI Tripura State Center, Engineer Vivekananda Ray, State Committee Member, Electrical Engineering, IEI Tripura State Center, and Dr. Bikram Das, SMIEE, USA, Assistant Professor, Department of Electrical Engineering, NIT Agartala. We are going to start our today's program. So I would like to request Engineer C. Devnath sir. We have with us Dr. Ithoraj Sen. So I would request Engineer C. Devnath sir to hand over the memento to him. I would like to request Engineer C. Devnath sir, Chairman, IEI Tripura State Center, to start our today's program by delivering his welcome address.
Good afternoon. Respected President of the Institution of Engineers India, Dr. Hemanto Thakare, the first President of the Institution of Engineers India, Engineer Shishir Kumar Banerjee sir, the Chairman, Electrical Engineering Division Board, IEI, Dr. Sudhir Kumar Kalla ji, the chief guest of today's program here in this Institution of Engineers, IEI Tripura State Center, Engineer Mahananda Debbarma, who is Director General, Tripura Renewable Energy Development Agency. In our program, Engineer Debashish Sarkar, Managing Director, Tripura State Electricity Corporation Limited, was supposed to be present as inaugurator, but due to some important meeting with the official of ministry, he couldn't come till now, but he will be joining with us later on. The Chairman of Electrical Engineering Division Board, IEI Tripura State Center, Dr. Priyanath Das, the Honorary Secretary, Dr. Subodhi Bhattacharya, the State Committee member, Engineer Vivekananda Rai, our advisor of Electrical Engineering Division, Engineer Subhash Chaudhary, who is also our past chairman. The speaker of today's program, Dr. Ranjan Kumar Behera, Professor, Department of Electrical Engineering Department, IIT Patna, Dr. Oshim Datta, Associate Professor, Department of Electrical Engineering, Tezpur University, and Dr. Tirtharaj Sen, Principal, Women's Polytechnic. The participants and corporate members who have joined with us in this one-day seminar, and the beloved engineering students, faculty members. In our today's program, I would like to take the privilege to welcome all of you in the one-day seminar on power converters and drives for electrical vehicles in connection with the celebration of 32nd Foundation Day of the Institution of Engineers India Tripura State Center, being organized under the aegis of Electrical Engineering Division Board IEI and jointly with Department of Electrical Engineering NIT Agartala and Department of Electrical Engineering Tripura Institute of Technology. The Institution of Engineers India Tripura State Center has started its journey in 1989 in the shape of ad hoc as Agartala Local Center and got recognition by the headquarter in 1991, 1st April as Agartala Local Center, and it was then under control of Assam State Center. And we are happy that the Institution of Engineers headquarter has recognized us as Tripura State Center from 2008 December. And in the meantime, we have completed 32 years of journey, including the period of Agartala Local Center. And during this period, we have organized many technical activity, national, international, state level, as well. We had organized many training program and other activities also. So today, in connection with this 32nd Foundation Day of the Institution of Engineers India, Tripura State Center, which was started on 1st April by flag hoisting in the morning, and in the evening, the ceremonial inaugural program. Next day, on 2nd day, there was a one-day seminar of Civil Engineering Division. And yesterday, on the 3rd day morning, there was a general discussion by the corporate members and engineers, followed by in the evening in cultural program and family get-together. And today we have in the 4th day, the one-day seminar of Electrical Engineering Division. We are very much happy to welcome our President of the Institution of Engineers India, Dr. Hemant Thackeray. In spite of his busy schedule, he could manage time to grace the occasion of our Foundation Day program. In fact, we had invited him to be in our all programs, but he had consented to be present in the Civil Engineering Division program on 2nd April, as because this branch is connected with him. But due to some other program, in the last moment, he had to cancel and assured us that at any one day he will come. And yesterday he confirmed to grace the occasion of this 4th day program. And we are really happy to have the kind presence of Dr. Hemant Thackeray. On behalf of all the corporate members and the engineers of our state, I especially welcome you and also invite you to kindly visit our state so that we may hear from you by the corporate members, the engineers, in regards to the technology development as well as our functioning of the Institution of Engineers India. So I once again welcome Dr. Hemant Thackeray. Engineer Shishir Kumar Banerjee, the past president of the Institution of Engineers India, who has a long connection with the engineers of Tripura, have given consent to grace the occasion in our today's program. I, on behalf of all the corporate members and the Institution of Engineers India Tripura State Center, would like to take the privilege to welcome you, sir. And I hope today's your deliberation and speech will encourage us to do our best in regards to our activity of the center. Dr. Sudhir Kumar Kallaji, the chairman of Electrical Engineering Division Board IEI, who has given the clearance to organize the one-day seminar of Electrical Engineering Division on the topic power converters and drives for electrical vehicle. I welcome you, sir, in this program, and I hope through your deliberation and speech, we may get something to do our future activity from the electrical engineering division committee also. I welcome Engineer Mohanando Deborma, the Director General Tripura Renewable Energy Development Agency, who is the chief guest of today's program. Our inaugurator, Engineer Devashish Sarkar, will be joining with us shortly. In our today's program, we have three presenters, two presentation on online. Dr. Ranjan Kumar Behera, Professor, Department of Electrical Engineering, IIT Patna, who will be delivering his presentation on utility-friendly high-power converter for electrical traction and industrial applications. And another one presentation on online, Dr. Osim Dotto, Associate Professor, Department of Electrical Engineering, Tezpur University, on the topic electric vehicle and motor drives. I welcome both of you in this today's program, and I am very much confident that our participants, the faculty members, the engineering students will be immensely benefited through your deliberation. Dr. Tirthraj Sen, who is our convener of Electrical Engineering Division also, he is the principal of Women's Polytechnic, and he will make presentation on magnetic circuit calculation for design of electrical machine, who is present here. I welcome you in this program, and I hope your deliberation will be encouraging our participants, and there will be good interaction after the deliberation also. I welcome our Chairman, Electrical Division Board, Dr. Priyanath Das, Advisor, Engineer Subhash Chaudhary, and our committee member, Engineer Vivekanand Rai, Honorary Secretary, Dr. Subodhi Bhattacharya, our moderator, Dr. Bikram Das, and the corporate members, faculty members, and the engineering students in our today's program. The topic chosen for our today's one-day program is power converters and drives for electrical vehicles. It is well known that our conventional fossil fuel reserves are finite, and transportation sector is one of the major consumers of fossil fuels. It is evident that due to combustion of fossil fuels, air pollution is also increasing day by day. In order to avoid this major challenge, it is the need of the hour to explore for alternative sustainable technologies. One of the most promising alternative technologies in today's world, integration of electrical vehicle in transport sector. I hope the deliberation which will be made by our three esteemed speakers will be immensely benefited for our participants, and also and subsequently it will be circulated to others also. In connection with our program, the 7 days program, today this is the 4th day, tomorrow the mechanical 1-day program, and day after tomorrow the electronics engineering division, and then chemical engineering division, followed by the closing ceremony in the evening, when the recommendation of all the 5 1-day seminar will be made, and it will be sent to the headquarters for a due concurrence, and afterwards we shall be submitting this recommendation through headquarters to the concerned authority so that it can be implemented. For kind information of our Honorable President, First President, and Chairman, Electrical Division Board, sir, as and when we are organizing any technical activity since our inception, we would like to see that this recommendation should be submitted to the concerned authority so that it can be ultimately implemented in due course. And for your kind information, I am really happy to inform you that when we had organized technical seminar here in regards to power generation, our advisor engineer Subhash Chaudhary presented paper in 1998, and after that the recommendation was submitted to the government of Tripura, and on request of government of Tripura, our president, then president of Institute of Engineers, Dr. MP Chaudhary, had arranged one meeting in Delhi in presence of CMD, IOC, CMD, ONGC, and also chief secretary was invited, but in the last moment he sent the principal secretary. And today there is a 700 megawatt power project in Tripura, that is Palatana project. This is the outcome of that seminar. And also we had our joint program with Bangladesh Institution of Engineers in Dhaka, where the power minister of Bangladesh was present, and from our delegation, the MD of OTPC Limited was present, Mr. Satyajit Ganguly. And in that meeting, the power minister of Bangladesh had requested the MD OTPC to see for transfer of surplus power to Bangladesh, and subsequently it was taken up and government has decided to transfer some surplus power to Bangladesh. In this way, in many occasions, we had submitted recommendation and government taken up this thing for due implementation. And we are really happy that in our state, the government of Tripura is giving much importance on the activity of the Institution of Engineers India. And that's why they have given this plot of land in this prime location of our state. And ultimately, till now, we have completed a 4-story building with the support of ONGC and others, and obviously the headquarters. The next floor is meant for the auditorium. I hope after completion of this auditorium, we can organize all the program in our venue. And just another one information, that throughout the year, we are conducting technical activity involving the engineers, faculty members, and engineering students. We have introduced two unique things. One is joint venture program with other centers like the Institute of Engineers, other centers, Delhi, Punjab, etc., and also Bangladesh, Nepal. And after the joint venture program, also we are submitting recommendation to the government. And another one introduction is Saturday seminar meant for the engineering students. Every Saturday there is a seminar that is in alternate month, branch wise, and in this way, the engineering students, right from diploma level to PhD level in our state, are very much involved in the activities of the Institution of Engineers India. And I am really happy to mention here for our participants that when there was a council meeting in Hyderabad recently, I have seen in the records circulated by the headquarters, out of 125 centers in regards to technical activity, our position is third one. It is really encouraging for us the way we are getting support from our faculty members, the engineering students, engineers, and also obviously the committee members. We can continue such type of activity so that ultimately the Institution of Engineers India Tripura State Center can do something in the development of our state. So with this, I once again welcome all of you, especially the President of Institution of Engineers India, First President, and Chairman Electrical Engineering Division. And I hope today's seminar will be a grand success with the presentation of the experts and also followed by interaction, and above all the deliberation of our President, First President, and the Chairman Electrical Engineering Division Board will be encouraging us to do our best in the development and the development of our state as well as development in the technology. Thank you very much.
Thank you, sir. Now I would like to request all our dignitaries to please come forward and torch the sacred lamp. Thank you, gentlemen. I would like to request Dr. Priyanath Das, Sir, Chairman, Electrical Engineering Division, IEI, Tripura State Center, to say a few words on this auspicious occasion.
Good afternoon to all. Respected inaugurator of the program, Engineer Debashish Sarkar, Managing Director, Tripura State Electricity Corporation Limited, Agartala. President EI, Dr. Hemant Thakre, past President EI, Engineer Shishir Kumar Banerjee, and Dr. Sudhir Kumar Kala, Chairman, Electrical Engineering Division Board, IEI, Engineer Mahananda Deparma, Chief Guest today's program, and the Managing Director, Director General, Tripura Renewable Energy and Development Agency, Engineer Dr. Today's expert, Dr. Ranjan Kumar Beda, Professor IIT Patna, and Dr. Oshim Dotto, another experts, Associate Professor and Tezpur University, and third experts, Dr. Titoraj Sen, Convener of the Electrical Engineering Division, Tripura State Center, and Principal Women Polytechnic College, and our advisor, advisor Electrical Engineering Division, Engineer Subhash Chaudhary, and the Chairman IEI, Engineer Chinmoy Devnath, and the Honorary Secretary, Dr. Shubhodip Bhattacharya, and other distinguished engineers and members of the IEI, and my dear students, faculty members. It's a great privilege for me to say few words regarding the activities of IEI Electrical Engineering Division. Due to COVID pandemic situation, we could not conduct the physical webinar or workshop, but still during the last 1 year, we have organized 6 numbers of webinars, that is the bi-monthly webinar on different technical emerging topics where the experts from IITs, NITs, TITs, Tripura University, and also the industries from the ONGC, NIPCO, they have given their valuable lectures on virtual mode, that is the online mode. IEI Electrical Engineering Division is taking great role to bridge among the industries and the institutes for interaction regarding latest technological issue and sharing knowledge between the students, faculties, and the practicing engineers. It creates a bridge, it creates a bonding between the professional engineers as a whole. IEI Electrical Division is also coordinating all the technical institutions of the state with a different department like ONGC, TSCCL, NIPCO, for exchanging their practical knowledge amongst the researchers, students, engineers, and also upgrades the engineering skills by organizing different seminars, workshops. So same way, today also we are going to organize a one-day seminar on power converters and drives for electrical vehicles. This is the emerging topics right now, and people are doing their research, and also in future it will play a great role for the transportation purpose. And the today experts, speakers from IIT Patna, already I told, the Professor Ranjan Kumar Beda, and also the Oshim Dotto from Tezpur University, and Dr. Prithviraj Sen. So hope we all will be benefited from this seminar. And lastly, I thank you all and wish grand success of the seminar. Thank you all.
Thank you, sir, for your valuable words. I would like to request Engineer Vivekananda Ray, sir, State Committee Member, Electrical Engineering, IEI, Tripura State Center, to introduce our guest to all our audience.
Dr. Hemant O. Thakreji, President of the Institute of Engineers India, is PhD holder in civil engineering, having 35 years of rich experience in engineering, social, and educational field. He is currently working as a director of a company. Dr. Thakre was a professor of an engineering college based at Nagpur. He is a dedicated soldier at Institute of Engineers India with his association of about 35 years selfless service and devotion. Engineer Shishir Kumar Banerjee, past president of IEI, has been associated with IEI Council for over a decade. He is an acclaimed civil engineer with specialization in water resource investigation, development. Engineer Banerjee hold position in significant responsibility, evident his tenures with many bodies, organization in various capacities in the past, such as Chairman, Indian Engineers Federation, Secretary General, FETO, West Bengal. Dr. Sudhir Kumar Kalaji, Chairman of Electrical Engineering Division Board, IEI, completed Bachelor of Engineering in Electrical Engineering and joined in Rajasthan State Electricity Board as Assistant Engineer during 1971. And after getting merit promotion year by year, in 2008, he attained highest position in the organization as Chairman and Managing Director, Rajasthan State Generation Company. During his service, he completed ME Electrical and ME Electrical in 1983 and PhD in 1986 from Malabo Regional Engineering College. Engineer Debashish Sarkar, MD of TSECL, completed Bachelor of Engineering in Electrical Engineering in the year 1986 from Jadavpur University, Kolkata, and joined in Calcutta State Electricity Supply Corporation, known as CSC Limited, Ranchi subsidiary, in the year 1987. He also worked at Toronto Power Limited and India Power Corporation Limited, holding position of significant responsibility. During 2020, he joined in TSECL as Director Technical and presently working there as MD and Director Technical. Engineer Mohanananda Burma, Director General of TREDA, completed BTech in Electrical Engineering from Nerist, Arunachal Pradesh, and joining Tripura Power Engineering Service in the year 1994. After getting promotion year by year, he attained highest position in the organization in the year 2018 as Chairman cum Managing Director of Tripura State Electricity Corporation Limited. Engineer Mohanananda Burma is a corporate member of the Institute of Engineers India, with his association of more than 25 years of devotion. Dr. Ranjan Kumar Behera, SMIEE USA, Professor, Department of Electrical Engineering, IIT Patna, the speaker of today's program, was a recipient of Bharat Vikas Award, Institute of Self-Reliance, Bhubaneswar, 2017. He has guided more than 8 PhD scholars and also completed not less than 7 R&D projects. He has published more than 55 papers in Journal of Report and Conference Proceedings. Apart from contribution mentioned above, he has also served in different administrative responsibility at IIT Patna, like HOD, Chairman, Member, etc., in different committees. Dr. Oshim Dotto, MIEE USA, Associate Professor, Department of Electrical Engineering, Tajpur University. The speaker of today's program is a recipient of ISTE Syed Sajid Ali National Award 2017, confirmed by the ISTE. He has more than 18 years of teaching experience. He is presently serving as a head of department. He is also guiding 3 PhD scholars at present. Dr. Tirtharaj Sen, FIE Principal of Aumel Polytechnic, Agartala, the speaker of today's program, received bachelor degree in electrical engineering during 1989 from Tripura Engineering College, presently NIT Agartala, and MTech and MTech in electrical power from University College of Science and Technology, Calcutta University during 2008. He received PhD from Jadavpur University, Kolkata in the year 2014. Dr. Shan served as an assistant professor, HOD, etc. at Bengal Institute of Technology and Management, Shantiniketan, Asansol Engineering College from 2005 to 2015. Thank you.
Thank you, sir. I would like to request the moderator of our today's occasion, Dr. Bikram Das, sir, SMI EEE USA, member IEI, Assistant Professor, Department of Electrical Engineering, NIT Agartala, to carry forward the occasion. Thank you.
Thank you. Thank you for handing over the microphone to me to carry out the program. May I now request Professor Dr. Sudhir Kumar Kalla, Chairman, Electrical Engineering Division Board, IEI, to deliver his speech. May I request once again Professor Dr. Sudhir Kumar Kalla, Chairman, Electrical Engineering Division Board, IEI, to start his speech.
Yeah, good evening to everybody. Dr. Hemant Thakre, President of the III, past President of the III, Engineer Shishir Banerjee ji, Chief Guest of this program, and Mr. Chinmay Devnath, Chairman of Tripura State Center, III, Dr. S. Bhattacharya ji, Honorary Secretary of Tripura State Center, III, Professor Dr. the eminent speakers, Professor Dr. Ranjan Kumar Behra ji, Dr. Ashim Datta, Dr. Tirthraj Sen, Dr. Bikram Das ji. First of all, I am really, and all the participants present in this webinar. First of all, I congratulate Tripura State Center for choosing a very excellent topic of power converters and drives for electric vehicles. In fact, electric vehicles is very close to my heart due to the fact that when I was in United States, I was driving the electric vehicle of the Tesla make. In USA, I also visited a number of Tesla electric car industries and found that a lot of modifications and innovations are going on in this field. And I found that these electric vehicles in USA in 2030, they say that all the electric vehicles will be replaced, all the vehicles will be replaced by the electric vehicles by 2030. That is their aim. A lot of other companies also making these electric vehicles. In India also, now there is a challenge, and people are in this national level, they have taken up that electric vehicles to be introduced, in fact. And since I have also visited a lot of institutions in US also and in India also, and therefore one thing I want to say that the coming time is for the electric vehicles. The main point is that today the internal combustion engine is gradually being replaced by electric motors, which results in higher efficiency and low emission of greenhouse gases. The electric vehicle either works wholly or partially on electrical energy generated from batteries and ultracapacitors. The battery or ultracapacitor is either charged from the AC supply connected to a grid line in a plug-in electric vehicle or from ICE in a hybrid electric vehicles. Alternately, the battery charges from the traction motors by regenerating braking. In the reverse direction, the energy from the battery or ultra capacitor is injected into the AC grid line in the plug-in electric vehicles. The power electronic converters, which is the topic of this webinar also, plays a vital role in the conversion process from grid line to the traction motor and in the reverse directions. There are a lot of advantages for these electric vehicles, that this makes a pollutant free and more efficient, high performance, and increases the durability of the vehicles. Besides this, there are a lot of advantages. A lot of type of electric vehicles are being in the market, and there is a role of power electronics converters also on these electrical vehicles. The electric vehicles use electric energy to drive the vehicle and for the electrical appliances in the vehicle to function. According to the International Electrotechnical Commission's Technical Committee, if the vehicle uses 2 or more energy sources, storage device, and converters to drive the vehicle, then it's called a hybrid electric vehicles. The hybrid electric vehicles are also very popular nowadays in the market. But after having so many advantages of the electric vehicles, but we have got a lot of challenges also in the power electronics vehicular systems. First is the improve the efficiency. How to improve the efficiency is the main challenges, because the efficiency of the PEC depends on the number of components, control strategies, and EMI effects. Secondly, to increase the durability of the electric vehicles. The durability of the electric vehicles depend on the life of the electrical unit present in the electric vehicles. The durability of the battery increases by continuously maintaining the charging and discharging level with the help of the voltage controller. Third is the increase the performance of the electric vehicles. Fast and high power industry motion control is a demanding trend in the modern automobile system. The PEL techniques is combined with digital signal processing to achieve the high performance of the electrical vehicles. Fourth is increase the luxury features. Today's advanced electric vehicles are more focused on making high comfort electric vehicles. Some high comfort applications are there in each application, which requires different voltage rating to the work. The AC load receives power from the 3-phase inverter, and that's why they can help in increasing the luxury features. Fifth is the increase the safety in electric vehicles. That is very important in the electric vehicles, because apart from the power conversion and propelling control, monitoring the condition of the traction motors to detect any failure like stator, rotor, and bearing faults are very essential. In advanced electric vehicles, ABS and airbags require high power actuators. The PC and DSP techniques can increase the safety features in electric vehicles in future. And last point is decrease the overall cost of the electric vehicles, which is the very important thing, and a lot of innovation and modifications are going on in the electrical vehicles, and how to reduce the cost of the electric vehicles. But the main cost is depend on the battery of the electric vehicles, and therefore there are a lot of innovation and renovations are going on to reduce the cost of the battery. And as the luxury load increases on the vehicles, it is responsible for demanding a higher number of PEC. The challenge is to reduce the cost of the vehicle by selecting a smaller number of power conversion units for a more significant number of luxury loads. So this is the way that we have the electric vehicles has got tremendous scope for the improvement in the thing. National side also, there are electric vehicles are coming up in a fast way, but the main challenge here in India is about the power availability and the charging stations, which is very much required. So this is the whole point about this. Regarding this Institute of Engineers, as a chairman of the ELDB, I will request Tripura State Center and all the state centers that they should conduct more seminars on the various topics, one day or hybrid mode and different way, 2-day seminar. They should conduct a lot of seminars. One thing I will also want to mention here that we are going to issue the annual technical volume every year. So this time also we are publishing the annual technical volume. So we request that a number of papers on the theme of the annual technical volume may be submitted or sent to the headquarters of our electric division board so that we can select it. And the topic chosen is very, very of useful nature. And I wish a grand success of the seminar, this webinar. Have a nice time. Good day. Thank you.
Thank you very much, sir, for your nice speech, starting from your experience at Tesla and different innovations to be carried out. Whatever you have discussed, you have not left any portion of the electric vehicles, starting from its safety, converters, vehicles, different integration with the hybrid mode. So it's a very encouraging and innovative speech being delivered by President Electrical Engineering Division, Chairman Electrical Engineering Division, IEI, Professor Dr. Sudhir Kumar Kalla. Once again, I thank you, sir, for your wonderful presentation. May I now request Dr. Hemant Kumar Thakre ji, President IEI, to deliver his speech.
Thank you, Moderator Dr. Vikram Das ji. Good evening, all. Past President of IEI, Engineer Sisirda, Chief Guest, Engineer Mahananda Debarma, Director General, Tripura Renewable Energy Development Agency, Professor Dr. Sudhir Kumar Kalla ji, Chairman, Electrical Engineering Division Board, Engineer Chinmay Devnath ji, Chairman, IIT Tripura State Center, Dr. Debashish Bhattacharya ji, Honorary Secretary, IIT Tripura State Center, Dr. Priyana Das, Convener, Electrical Engineering Division, Tripura State Center, Committee Member of State and Local Center, Corporate and Student Members, dignitaries, delegates, participants, ladies and gentlemen. This is a great opportunity for all of us to be a part of technical webinar on power converters and ties for electrical vehicles being organized by the Tripura State Center under the aegis of Electrical Engineering Division Board on the occasion of the Foundation Day celebration of the center. The effort of the institution has always been to keep its members informed and abreast about the latest engineering and technological developments occurring in national and international arena through conduct of technical events involving eminent professionals and practitioners. Over its last 100 years of existence, the institution has provided valuable suggestions and policy inputs to the policymakers contributing to the national goal. Coming to today's topic, it is imperative to mention that the shifting to the electrical vehicles is need of the hour, considering the fact that conventional fossil fuel reserves are finite and depleting, and transportation sector is one of the major consumers of fossil fuels. Also, introduction of e-vehicles will address the issue of pollution and air quality due to zero emission. These two are the biggest advantage of the e-vehicle besides cost effectiveness and easy maintenance due to less movable parts. Electric vehicles include 4 systems: the battery, the traction motor, the motor driver, and the unit of control. For successful operation of electric vehicles, efficient power converters and drives mechanism in the system is very much significant. Under this above backdrop, the theme of today's webinar to be organized by IIT Tripura State Center is very appropriate. It is expected that today's webinar will provide a platform for students, faculty members, and practicing engineers to exchange their knowledge and ideas in the field of electrical vehicle and the technology development. Thanking you all and wishing the webinar all success. Thank you.
Thank you very much, sir. We are very much delighted with the wonderful speech that you have given, which has also motivated us to continue with the further or more such types of webinars and activities to be carried out under the aegis of this IIT Tripura State Center. Once again, thank you for your presentation, sir. May I now request May I now request Engineer Shishir Kumar Banerjee, past President IEI, to deliver his speech.
Our Honorable President, Mr. Hemant Thakre, our Chairman, Electrical Engineering Division Board, Professor Sudhir Kumar Kalla, Chairman of the Tripura State Center, Engineer Bhomik, Engineer Devashish Sarkar, Professor Ranjan Kumar Behera, Dr. Ashim Datto, Dr. Tirthanjan Sen, Dr. Vikram Das, and also Piyuna Das, Vivekananda Lai, Subhas Chaudhary, and Honorary Secretary Shubhati Bhattacharya, and our particularly Professor Ranjan Kumar Behera, Department of Electrical Engineering, the corporate members, council members, faculty members, and senior technicians, ladies and gentlemen, a very good evening to all of you. It is a momentous occasion when Tripura State Center of the institution is celebrating its
Sir,
32nd
from Tripura Center, sir, can I request you to be slightly louder or take the microphone near you? Because you are not that much of audible to us, where we have about 60 to 70 participants here. Slightly louder or take the microphone near to you. Thank you.
Now, now it is okay? Now
Yes, sir.
it is now okay?
Yes, sir.
Okay, okay, thank you. It is a momentous occasion when Tripura State Center is celebrating its 32nd Foundation Day, and it is my proud privilege to address this August gathering on this occasion. And during the deep pandemic situation with strictly imposed restrictions, technical webinars are being conducted by the institution on contemporary topics on regular basis, which provide a virtual knowledge sharing platform for our corporate members and the professional attached to the domain. Large number of automobiles in use continues to cause serious hazards in environment and human life, which include air pollution, global warming, rapid depletion of Earth petroleum resources. Electric vehicles, hybrid electric vehicles, and fuel cell vehicles have been proposed to replace conventional vehicles in the near future to overcome these limitations. Most electric and hybrid electric configurations apply to energy storage devices, one with high energy storage capability, named as main energy system, and the other with high power capability and reversibility, known as rechargeable energy storage system. Main energy system provides extended driving range, and rechargeable energy storage system provides good acceleration and regenerative braking. Energy storage or supply devices vary their output voltage with load or state of charge, and high voltage of the DC link create major challenges for vehicle designers when integrating energy storage supply devices with a traction drive. DC-DC converters can be used to interface the elements in the electric powertrain by boosting or chopping the voltage level. Due to the automobile constraints, the power converter should be reliable, lightweight, small volume with high efficiency, low electromagnetic interference, and low current voltage ripple. We are eagerly waiting to hear from the Honorable Chief Guest of the function and eminent panelists of this session. We hope that the roadmap to shift from conventional vehicle to electric vehicle to combat the environmental pollution with subsequent cost effectiveness be explored during the thoughtful deliberation. We also hope that the challenges to implement the switchover with the infrastructure requirement be discussed through. With these few words, I conclude my address. Again, congratulate Tripura State Center and wish the evening a grand success. Thank you all.
Thank you very much, Engineer Shishir Kumar Banerjee, sir, past President IEI. For delivering a wonderful lecture regarding the electric vehicle. And he has rightly pointed out that what are the merits, what are the challenges, and what may be the different types of electric vehicles that can be incorporated in near future. Thank you very much, sir. May I now request the chief guest of the program, Engineer Mahananda Debarma, sir, Director General, Tripura Renewable Energy Development Agency, to deliver his speech.
Respected Dr. Hemant Thakre, President, Indian Engineers, Institute of Engineers, India, past President, Engineer Shishir Kumar Banerjee, Chairman, Tripura State Center, Engineer Siddharth, Dr. Priyanath Das, Chairman, IEI, Agartala, Tripura State Center. Today's inaugurator, Engineer Devashish Sarkar, MD, TSCCL. Engineer Vivekananda Rai, State Committee Member, IEI, Tripura State Center. Professor Dr. Sudhir Kumar Challa, Chairman, Electrical Engineering Divisions, IEI. Engineer Dr. Ranjan Kumar Behera, SIV USA, Professor IIT Patna, Dr. Ashim Datta, MIE USA, Associate Professor, Tezpur University, Dr. Tithoras Sen, FI, Women's Polytechnic, Tripura, Agartala. Respected Engineer Subhash Choudhury, Advisor, Electrical Engineering Divisions, IEI. Dr. Vikram Das, Dr. Shubhodip Bhattacharya, Honorary Secretary, IEI. It is a privilege and honor for me to be here as a chief guest to deliver a speech on the topics which has been chosen on the 32nd Foundation Day of the Institute of Engineers, India, Tripura State Center. The subject, the very relevant on this today's chapter, the new era is likely to begin in the system. The motor vehicles, the four-wheeler, two-wheeler, irrespective of any type and the size of the vehicles, to be converted to the electrical vehicles. A lot of R&D already on set, and a lot of improvement has already taken place on the sector. The topics is chosen for the converters, DC to DC, AC to DC. I'm very much thankful to the speakers, the expertise, those who have touched upon the topics for technology and which would be the best choice for us. But India being our big country, we have a lot of diversity in the country. The limitation of the resources, the reliability and the stability of the systems, all has to be taken into considerations. The states, the country has taken a lot of statutory wood on set for the regulations, rules and regulations, the logistic, the support that has to be set on before we move on to the converting the entire shift on this electric vehicles. The basic drive for converting choice by the individuals is on techno-commercials. We have seen now the prices of cost of the prices of the diesels and the petrols And if taking into consideration of the electrical vehicles, we have seen now per kilometer cost of the driving the electrical vehicle comes to the 1 or 2 rupees. Whereas by the diesel petrol, it goes now around 10 rupees, 15 rupees, something like that. So there's a major shift. The choice goes automatically by making a techno-commercial aspect of the individuals. That is in long run. It basically now since the initial investment, initial cost being little high on the electrical vehicles, the choice is not getting now promoted. So now taking into consideration all these factors, now the basic requirement for this having an electrical vehicle, he has to have a charging stations by the individuals at his house premises. For the commercial sector, it has to be in the commercial premises, and for industrial sectors, then to the highway, then the national highways, all this has to be there. So in Tripura, what we have seen, now for the petrol, diesel, they have the storage capacity, they have the storage systems. So whenever the vehicle goes there, they get the petrols, they take the petrols, diesels as per their requirement. But it is not unlikely to happen in the electrical systems. Electrical has to be live, electrical has to be continuously available in the system. In the city area, the urban area, that can be easily made possible. But in the highway, in the roadways, that may be little, there may be some challenges there. We every year, every season we face the monsoons, the cyclones, rainy, all these factors are there. So unless the stable power supplies there along the highway, along the roadways, then we traffic, there would be vehicles would be stranded there in the charging stations, and there may also likely to happen the grid collapse, network collapse. All those factors has to be taken into considerations. Now, therefore, the choice is now we have to have a multiple choices. That is why the hybrid kind of charging stations, hybrid kind of converter has to be put in. Sometimes solar power has to be needed to make it economically more viable, because conventional power is going to be higher and higher. We have seen it. A lot of integrations of the renewable sectors are there. Because of that, the availability of power is there. Mostly in the daytime, the power supports are there for the renewable sectors, but in the evening time, the power has to be from the conventional power sector, the system. So to keep this conventional power to be alive in the system, the cost has to be, somebody has to be borne. Taking into fact all the sectors of the capital cost, of this running cost of the asset, all these sectors, the present average power cost may be 7 rupees, 6.5 to the 7 rupees per unit. It will likely to go to 10, 15 rupees, something like that in the days to come. So taking into all the sector now, there should be a renewable sector integration in the system. Again, there is challenges in the renewable sector also. Solar, suppose solar is easily available, it can be tapped here in the state of Tripura. Now, if there's a cloudy, there's a rainy, again challenges there. Power, the energy may not be available to that extent. What is the required for that? So there again, by the charging stations, battery system has to be there in all the charging stations, or either a disease set has to be there in the charging stations. All has to be taking into all this factor. Then again, for having the individual to at their household, the premises to having a charging stations, there should be a system has to be there. So the power utility, the DISCOM, they have to have their strong network. They have to be capable for supporting the systems, augmenting their system, augmenting their supply cables. All this has to be there. So these are the sectors now, particularly for promoting the electrical vehicle. Many of the states has drafted, many of the states has already notified the draft, this electrical vehicle policies. In Tripura also, it is on draft stage. I have gone through the draft. I have seen very favorably it has been drafted. I believe in the days to come, the people will prefer for the electrical vehicles, and the R&Ds are also going on for converting the existing vehicle to the electrical vehicle. These are also the issues. So now we talk about the converter now. We are not talking about the inverter, but there may be requirement of the inverter also in the certain cases. So those factor has also to be set in. So that is why we call it hybrid kind of conversions. That may also be the requirement for in our days to come. That may be the sector. These are the requirement. So I'm very much thankful for this on this August House. Many of the engineering students are there here present, and they are our future. They will have all this beauty of the clean energy driven the systems. And it is our need of our requirement also. Is a new era is likely to begin now. It has already started. So I'm very much thankful to the organizing committee and this Institute of Engineers, Tripura State Center. They have taken a excellent initiatives on this Foundation Day. The more kind of the issues likely to happen on the sector, I think it will be addressed on the same similar this the platform. So I am very much thankful. Thank you.
Thank you very much, sir, for highlighting about so many things, starting from the policy making, then rules and regulations, what are the techniques to be adopted for charging stations, and what are the various locations where it can be installed, and what are the complications that can be faced. Thank you very much for highlighting with so many things. Once again, I thank you very much, sir. Now the time for our presentation of paper. It's my humble request to the presenter to kindly look at the time. Time is 25 minutes for presenting. May I now request Professor Dr. Ranjan Kumar Behera, IIT Patna, to deliver his lecture on utility friendly high power converters for electrical traction and industrial applications. Please, sir.
Good afternoon. Is it audible to everyone? Sir, is it audible?
Can you please slightly be louder?
Okay. Sir, is it audible, sir?
So can you be slightly louder?
Sir, yes. Is it okay? Or just 1 minute. Let me change my mic to another one. Sir, is it audible, this one?
This is perfectly right, sir. Perfectly all right.
Okay, thank you. So I was just thank everyone for inviting me and thinking me I can deliver a talk among such a great personalities. And I'm humbly grateful to the Institution of Engineer Tripura. Many times I visited to NIT Tripura, NIT Agartala, and this time I'm giving this talk. Thank you very much. So today I will speak about utility-friendly converter for electric traction and industrial application. And I was just waiting for my talk because around 5:15 I have another meeting in the department.
So I will try to finish this one. So I will just give a brief one. Although I worked on the traction motor and high power industrial applications since 2003, I started my work for high speed train drive, and how the high speed train can be became integral part of Indian Railway. That was first project we got from Honorable Minister of Railway long back 2006. So till today, we develop many electric vehicles, not only one or two. And already my journey was my BTech, MTech from NIT Rourkela, IIT Kanpur, and I was a visiting professor at University of Pretoria and Tennessee Technological University. And my most research topic is on solar wind power. I have around 2 megawatt wind power project I have installed when I was working with General Electric G in Hong Kong. And also in USA, I have installed around 1 megawatt wind turbine as well as a solar also, starting from Port Blair Air Force Station 1 megawatt, and also the around Bihar around 25 electrical the solar electric integrating project with solar pumping and everything we have done in this Bihar with the help of G and Tata Power. So implemented in many places in Araria, in the Vaishali district, in Punya district, many remote villages we have integrated with the solar energy with variable diesel engine also, diesel generators. And we also work on wireless power and many electric vehicle we have designed. And with the cycle we started, and Agran Motors, which is in Vijayanagaram, is that one of the product. He is manufacturing, and thousands of cycles he has already sold. And if you see here, this is our portable EV we have started, and it will be launched in the government. It is incubated in IIT Patna, will be launched on 29th May of this year. We are launching this vehicle, portable vehicle for all the people. Intelligent solar pump and high power drives, LED drives, and the smart grid modules also. And we got also last year the from grid Power Grid Corporation in 2019. We got the smart grid module award actually for that. So this is a book. And these new technologies, just last week, we had a technology demonstration for the government of India and technology business incubation. They visited to IIT Patna, where we have developed many products from the robust fault-tolerant inverter, very high power inverter, which is today all the inverter high power above 100 kVA inverter we generally procure from outside and bring to India. But actually we developed the inverter up to 300 kVA capacity. Now we are planning to develop up to 4.5 megawatt MVA inverter also. So that is our target, a very high power inverter we can develop. And you can see that this in-wheel motor also, BLDC motor we have developed, and many motors technology also we are developed, and many are patented and also granted on this one. So, and this light which is we are showing, it is a this is a smart transmission system. When we have a long transmission system and medium transmission system and short transmission system, we do based on the power generation and utilization, or source power and sink power balancing. But here it is a prototype, and 5 kilowatt power, if it is there, long transmission line will operate, and when 3 kilowatt it will short transmission line, and 2 kilowatt it will be only the the 3 and 5, and 2 kilowatt it will short, then medium, and according to power limit. And it can easily generate all kind of power, everything you can see, whether the solar is integrated, also it will inform the power quality, all the thing you can unitedly we have designed. And last 2009 also, we presented in Grid Corporation of India in Delhi, where we got Grid Tech Award also for this project. So we have all this motor, all this technology, and these are our team members by which we develop one after another technology, starting from solar tree to compact solar energy to different electrical technology. And also we have developed with the help of National Mission on Power Electronics, we have developed these motors, and we transform many electric and this especially this induction motor we developed in the around 5 HP induction motor, and it is actually you can say that it is 80 hertz, because in India the roads are not similar and the roads are very rough and tough. So you require wide speed range. That's why 80 hertz, 110 volt and 5 HP. You can say that this motor is having the efficiency around more than 92% efficiency, this induction motor, and it is patented and also it is granted. And this project was sponsored by the Ministry of Communication and Information Technology, Government of India. It is developed now. Boom motor is taken this and they are developing now in Bangalore. They have launched last year. The 2-3 motor we have developed, one induction motor, and the second one is brushless motor. Another one we are in the development stage, that is axial flux motor, which is not developed till today in worldwide. Only one company they sells from UK, but it is very costly where people cannot afford it. And now also we have seen that the manufacturing cost, one person asked as 15 lakh rupees for one piece of axial flux motor because of the cutting in the slot cutting. That is the problem. So anyway, there are a lot of challenges, and I started with the Indian Railways. So we have when we want a electric vehicle, so I have many topic on electric vehicle and only machine and only converter, only and the inverters, then the motor technology and complete drive technology. So there are many, but I'll not go in detail of everyone. I will try to focus the innovations where you can think further for that. So the high power density, high torque, low speed for starting and climbing, and power while cursing. These are the different parameters, and I am not going, you can, the high efficiency, wide speed range, other things. So my work started with a utility friendly converter with this Indian Railway in 2006, long back. But till today we do working. And this we started when I visited to Paris, there the TGV. I studied the performance, and we try to imitate, develop the engine, okay, in the main power converter of a traction motor, which is 6,000 HP. It's very large, very high power. And then that how, because generally we have mainly diode bridge rectifier, which actually pollute the source of that one. And we have a pantograph, then overhead line to pantograph, then that generates large amount of harmonic. To solve that harmonic problem, we have started thinking about the utility friendly converter instead of a diode bridge converter. So this was the first converter which is we developed, and in the front end, this is our grid. So from the grid, we got this is our grid, is maybe 25 kV, and this is our drives. Okay, so when this one we set up, so first I will try to see the front end converter must be utility friendly. Utility friendly means it must draw sinusoidal current from the source and must be unity power factor, so that unity power factor, if it is maintained, always you can think that there is a maximum power transfer theorem will work there. V into I into cos phi. If cos phi is 1, maximum power you transfer to the source to load. So this is the concept where we used the utility friendly converter, where you do not require any reactive power compensation, or you don't require any reactive power. It is already compensated from the source side. So you no need to know about the desealing pollution. You no need to read about the EMI of the induction motor or winding stress, because this is a large amount of current it draws. So there is always stress in the winding and also vibration in the motor drive. So I will tell what is the vibration is a very, very important factor. When a large mass it moves in a like a traction motor, vibration must be minimal, or else little vibration, then the stability will come down. Similarly, I remember one 500 kilowatt permanent magnet synchronous generator we installed in the USA long back. And when as soon as we install and we came back, immediately there was only one stage gear ratio. And immediately when we get down, completely that converter, inverter, everything they burnt like a fire, large amount of fire came out. And that when I became astonished that how it was properly tested, checked, everything, what happened there. Just we after some time we went up and saw that there is one gear which is broken, one teeth in the gear, and there is a slippery motion. From the slippery that fire came and it burnt. That's what how the vibration itself is a very large amount. And we have many papers on simply vibration control in a ship propulsion engine also we studied. So that is what this is a simple multi-level converter, because in traction motor, the 2-level converter you can put in series or in cascaded based on the current and voltage requirement of the drive. But nowadays, because of the invention of a multi-level converter, so this is a simply a 3-level converter, high power converter, a design and fed to a resistive load, and want to control that one such that it will draw the unity power factor from the source, or it will have a sinusoidal current and draw unity power factor. So this is what the control technology is, hysteresis current control. Because why hysteresis current control became very popular? Because if you want to give a mechanical brake, it takes some time, inertia. And if you can synchronize the mechanical brake and electrical brake, your body will be balanced. And that is what the foreign, if you buy the car from other countries, and they have the perfect balancing in the mechanism, because the mechanical and electrical time constant properly should be matched. Or if the mechanical and there is some delay, then it may damage some time. So that is how hysteresis current control gives first dynamic response. As you give a slap, again slap will come very quickly. So that is what the first dynamic, and this is controlled in this way by using hysteresis current control. And in the closed loop control, because another control is that this voltage should be constant. If the C1, C2 are not constant voltage, this voltage is not constant, immediately you will see that there is a unbalanced current in your load side. And unbalanced current will, unbalanced voltage will be there. And as soon as there is a two unbalanced source and you have having a large inertial load, then that time it will start vibrating. And as soon as a mechanical vibration start, completely in few seconds, complete system will collapse. Because you are controlling the electrical side, the mechanical vibration side. And as soon as that will synchronize with the critical resonance of the power circuit, immediately that will amplify and that will destroy also. So that is why the balancing of these two capacitors is very important in case of a multi-level converter. So these are the few electrical equations that you can see here. Our this voltage is always remain constant. And you can see that both the current and the voltage are sinusoidal, so that it is utility friendly. And you can see here, they both are unity power factor they are maintained. And this is a 3-level converter output, and both the DC link voltage are constant around. And this is how our utility friendly converter is designed in this way. And similarly, you want that sometime railway engine is coming down in a sliding hill. So the power must, in initial days, if you see in our railway traction motor, initially there was a diode bridge converter. So when power comes, if the DC-link power increases, we have a lot of resistance block where you try to discharge those resistance and discharge the power in the resistor block, where it was wasted, or charge a battery that time little bit. But nowadays, the traction motor, first traction motor, which we, AC traction motor, which we purchased from Australia, which is Lucknow to this Delhi Shatabdi train. They have not put the, they put the utility friendly converter. When the downhill comes, the power will not will not absorbed by resistor, rather it will feed back to the source, and that is called regenerative power. And regenerative power also we have developed. You can see that they are also feeding at unity power factor back to the grid. So even though you are, whenever you are generating, it is feeding back to the grid. So these are the few simulation result with a different load change, other thing. So what is it today? The main challenge is the traction motor drive. So when there is a traction motor drive and a suitable high power fault tolerant switching converter, also very important. If you see inside the train engine, there is a big converter which is called the main inverter circuit for driving the traction, and another inverter circuit which is driving the auxiliary circuit like compressor, fan, blower, other things. All other things are used, that auxiliary circuit. And those converter, if there is a fault, so can you, it is require a lot of energy to remove again the complete converter, again put it to that one. That is, a converter must be fault tolerant, first thing. And it must be very high power. So I visited to some place, the Solar Energy Institute in Gurgaon. So I have seen they have up to 15 kVA, the test facility for 15 kVA. Other testing facility they do in other lab, but they certified. But actually we can develop very high power converter test facility anywhere. And I personally, when I visited to long back to ABB Switzerland, and where I came from there and developed a very high power converter for around 160 kVA inverter circuit for our traction motor, which I'll show you here in this. And then real-time digital controller and integration and deployment within that space. So that must be very compact also. And torque speed requirement and fast ripple-free torque. Like in Indian Railway, there is no ripple-free torque. Always you will find there is a jerking. So this motor starts from different kind of motors and the technology in with the application. And AC motors are very, especially the induction motor with large shaft. So I visited to many ship yard in Cape Town in South Africa when I was in Pretoria. So I visited many times. So I have seen that when the winding and on completely shaft, when that vibration, they have a lot of work on that vibration analysis and separation, because different kind of current wave come and stuck to this one. And then our adjustable speed drive come into picture. This adjustable speed drive are view, there are different kind of converter. Somewhere AC-DC converter for DC drive, VSI voltage source inverter for AC drive, current source inverter fed AC drive, cyclo converter, nowadays matrix converter fed AC drive. So when India government first started planning, so GTO was planned around 1994, and after that the GTO, then one converter was IGBT, then GTO. Now both the converter, RDSO, they've given that both the converter should be developed an IGBT. So there are many the EMUs and Millennium Rec for different speed operation. There are so generally these converter rating from 70 kVA the auxiliary, and we purchase from Alstom, Siemens, and Hitachi, all those companies, and we should develop in our India. And I think that it is not a difficult only, the trust is the most important thing. So this complete auxiliary converter structure and their package, if you see, I am generally very regular to Chittaranjan Electric Loco, you can find that it is a box, you cannot understand what is there inside. If you open the box, you can see that all these components are there. So present, the drive is the heart of the locomotive, and almost all drive in a locomotive we import from other side, whereas BHEL, the transportation division in the Bhopal. So we have, after development, we have given the complete mapping that how to develop very high power. And if we see this one, the power converter, this is the specification of 4-quadrant operation, and one inverter should run 2 traction motors. Okay, so these inverters must run, the main inverter must run the 2 traction motor, and all this is the specification where we started thinking. So initially DC drive was very popular, and it was started long back in 1720 when one Russian scientist, he used to cross a small pond. When his house is another side of pond, he used to cross, and he started developing this one long back. The Russian people, they have developed, and then this came, all this control be due to invention of the power semiconductor devices. And there are conventional AC drives like this. There is a front end converter, and then this was initially used. But when they developed large high power drives, converters like multi-level converters and a special converter of multi-pulse converter, so those became, now the people are using that one. So initially there was a scalar control, then field oriented control, because the engineers thought that let us control an induction motor like a DC motor. Why? DC motor, one axis you control, other axis is not affected. Similarly, so this is so this then field oriented control. I am not going in detail. And field, this is a very interesting, very fundamental. Then direct torque control, which is in 1996, invented by ABB. But it was patented by ABB. After that, it was very popular today in the drives industry. So this is the scalar control, where the phase angle, like scalar control means like in your house, there is a stabilizer. So stabilizer, you can control only the magnitude of voltage. That is called the scalar control. When you use a unified power quality controller, which can control both magnitude, phase, as well as frequency, and that is called a unified power controller. Those who have studied this power quality, they must be associated with that. And this controller, although very cheap, and today all kind of irrigation drives comes by this VYF controller. Initially there was a star delta starter, but nowadays all this irrigation pump motor comes, because the farmer can easily control this. And this vector control was, the initial paper came in 1969, and its name was trans vector control, and it is to control the induction motor like a DC motor, separately excited. Why? When you control the armature axis, it will not affect on field. When you control the field, armature axis will not be controlled. Whereas in induction motor, all these are very linked together like this, very coupled. So one phase you control, other phase will be affected. So how to do that? That is the technology called the vector control or field oriented control. So this control, how we can say, so how we do that one? Like you are in, like when you move, your both of your friend, you and your friend are moving at same speed, and you are the relative speed between both of you same, and you are moving parallelly. If you look each other, you will see that you are stationary. Like in Howrah station, two metro trains are moving together, and you are sitting in one train, other friend is sitting in another train, and both the same speed are same, and relative speed is nearly zero. You will find that both are, if you look each other, they are stationary. Exactly, there are three reference frames. One is stator reference frame, another is rotor and arbitrary. So what we do, when you want to see stator as a reference stationary, you sit on the stator, you will see that both are reference are stationary. You want rotor reference frame, sit on the rotor reference, you will see that the rotor is at constants at the stationary. So exactly the same concept is just mapped to the induction motor. So anyway, I'm not going, there are two type of vector control. One is direct, indirect, and those who are you can go through this one, and I have another just 5 minutes I have to note down. So then I have discussed the director control. The director control principle also similarly very beautifully designed based on space vector control, and we want to control directly the torque. So that is why this method is very popular, and I am not going detail of the information table, other things, but here you can see that this is the fabrication. And when I fabricated, it was a large challenge actually. And this was fabricated after 3 years of struggle, visiting to at least Germany, and then I visited to Switzerland. Then we made this converter, and it was really challenging. 7-layer PCB bus bar structure with all ingredient, and it was so robust. And till today, since last 2006, I developed this one, and till today it is so robust converter. There is no even switches are not failed. So this is the high power converter drive, and this we used here both the converter. One is front end, which is utility friendly. Another is load end, which is driving this complete unit. And this is our hysteresis current controller we used. And this side we used the direct torque control we used. And this complete drive we have implemented, and experimental waveform, you can see that we have matched together. And both the converter was operating from 2 PCs. This one from 1 PC, another one from 2 PC, and with a different type of torque profile and speed drive by a traction motor is implemented. And this is the speed profile we implemented. And this is the completed drive unit. You can see that this is a auto transformer controls this inverter, this converter circuit, and this transformer, this is the flow, and here is our DC link voltage, and this is connected to another here, this one, and this converter is controlled by this PC, and this is our traction motor load, and complete unit was designed, and it is a very then this was transferred to the Indian Railway. And these are the few results I am just doing. And this is the few test setup where we test all kind of induction motor, their efficiency, and then we put into then these motors are generally So you can see that this is our laboratory setup where we test all the motors in this one. So this is one of that. Then we have many the mechanical model and then classical EVs, then EV design. Then this is a recent four-wheel drive, a car engine drive. So we used the another kind of motor, open-end winding motors. So there are many basic. I am not going because I want to finish quickly. And there are two converters. Even if, because when you are traveling, if one converter fail, so another converter is there where it can operate very nicely. And like that, there are a lot of technologies, and you can go through our paper where two wheel, one is our front wheel and the rear wheel is and there are two battery pack and four inverters. So this is a completely robust one. And then we design the vehicle because it will go to very hilly area, all the urban drive, every kind of drive. So you need to model the vehicle dynamics. And we model this dynamic, and then there are acceleration, deceleration, there are many methods we used, and when the wheels turns, all those things, speed control, and so this is the complete unit is demonstrated. And also you can see here, we have a isolated battery pack and dual motor drive. And with that performance, we studied this complete unit. And then this, you can see that this is the battery balancing. It's very, very important point. When you are driving, first thing you should see that the battery, like one of my students just yesterday, he shown me that, sir, our battery will stay below the seat. I told, if below the seat, if you will put, there is some temperature rises and battery will start burning or start fire. So the person who is sitting on the seat, he will first burn. Battery should be on the front so that he can throw it the cycle and go away. So battery management is one of the best, very important thing. And we are also working on that one. You can see that below is the battery management. And there are a lot of things how to balance the batteries and what kind of balancing is required. So there are many things. So this is our circuit setup. You can see that we developed this one, a 5-phase motor drive, because when you go deep into the sea, if you have a 3-phase, one phase will burn, then you cannot again come back. It is so difficult. That's why you need to keep 2 or 3 motors just as a spare when you go deep into the sea. But here, the 5-phase induction motor can operate as 5-phase. If one phase burn, it will operate as a 4. If one phase burn, 4 and 3 phase, up to 2 phase, we are now up to 3 phase we have tested that automatically it will control. This is the 5-phase induction motor where it is used for ship engine drive. So like this is our lab where we have starting from smart grid. This is a grid integrated inverter with a StartCom facility. And this is the high power, this is induction motor drive unit distributed inverter is this one. And this is our smart grid module, which we developed. This is a matrix converter. Recently, we developed this one. We have applied patent for this 3 to 5 matrix converter. And this is a 3-level inverter. All the things our student develop in the labs, just starting from scratching, from drilling to soldering to complete development of this drive. So we don't take, our students are very expert in designing high power converters. So with this, I will stop here. If you have any question, there are many things to tell, but I have no time. I have to join another meeting 2 minutes. So if you have any questions or comment, I will be happy, or I'll stop here.
Thank you very much, sir. We are very much delighted to see your lab setups and experimental setups through the presentation only. It's our pleasure to have a look on that. I'd like to thank you very much for highlighting about this category of electric vehicles, hybrid electric vehicles. There are different types of converter, including the multi-level inverters. What are the actual applications? And you have highlighted about the different speed drive controls and different motor control techniques. So thank you very much for your wonderful presentation, sir.
Thank you, sir. I extend everyone that anyone want to do any hardware, so they can most welcome to our lab, and they can do. And many people, they come from different institute, and they can do, they can publish paper, and they can publish paper with their own guide's name. They should come and do real-time simulator also there. All the things are government given, so anybody can use. I invite everyone for this. Thank you, sir.
Thank you very much, sir, for extending such a help to us. We'll definitely try to have a look at your lab and come and work under your guidance, or we'll try to send some students also.
Yes.
Thank you very much, sir.
Thank you. So can I leave, sir, now? I have an.
Sure, sir. It's our
Thank you.
pleasure to have
Namaskar.
you with us. You can leave, sir. Thank you. May I now request Dr. Asim Datta, Associate Professor, Department of Electrical Engineering, Tezpur University, to deliver his speech on the topic electric vehicle and
Yes.
presentation.
Just
Sir, your video is not visible. Can you please adjust the camera? It is visible, but quite blurred.
yes, the presentation option I am not getting. Hello.
Sir, you are audible.
Yeah.
Like
But
maybe
this
louder.
presentation option, what is the problem?
Sir, you can start your.
Yeah. Just.
Feel comfortable.
Yeah. It is just starting. So is it okay now? Hello.
Yes, sir. It is perfectly visible.
Okay. So, first of all, I have to thank the Institute of Engineer Tripura section for organizing this one-day seminar on power converter and drives for electric vehicle in connection with 32nd Foundation Day, and moreover inviting me as a speaker. So without taking time, directly I am starting. Yeah, so here my topic is electric vehicle and motor drives. So we everyone know nowadays electric vehicle, it is a hot topic, and this electric vehicle nowadays is recognized as an alternative to come out from the oil crisis, moreover from the environmental pollution. So one thing I have to tell here, actually, this electric vehicle, though it is telling as a promising alternative to substitute this fossil fuel, still we are telling it is the future generation vehicle, right? We are not considering now also that much technically. means society, our society not accepting as a now current generation vehicle. That means lot of work required is there. So lot of whole world is working to make electrical vehicle to commercially available, but lot of challenges are there. I will give some overviews on current state of arts on electrical vehicle, motors and control, and slightly I will highlight what are the challenges. So here slightly on future I am telling, actually this electric vehicle, actually it is not new. In fact, whenever this battery and our electric motor has come, immediately this electric vehicle model has come and it is demonstrated. And previously also at the start of the 20th century also, electric vehicle was more popular compared to our IC engine. But later on, IC engine taken the market. There are some reason. Beginning, you see, fossil fuel, it was easily available. Moreover, energy density of the fossil fuel is very high. That is why only this IC engine taken the market. But now, again, whenever we are feeling crisis on the fossil fuel and we are feeling the environment pollution from this IC engine based vehicle, again we are thinking or we are diverting toward the electric vehicle. So technology wise, if technology wise, if I consider on electric vehicle, there is main three section is electric propulsion subsystem, electric source or battery or energy subsystem, another is auxiliary subsystem. And electrical subsystem here is the main thing, mainly power transfer from battery source to our mechanical system, mechanical wheel rotation, this one through the electric motor and it control converter. Obviously, the power transfer to adjust the speed and torque should be as per the control from the driver through the brake and accelerator. So that is why here is converter is used. And energy system, obviously, it is the main input of power. It is involve battery cells depending on the electric vehicle, and moreover is charging system. So this depend on the type of the electric vehicle. So electric vehicle, it is a diversified field. So it is not only the our road or rail engine based vehicle or traction drives. Electric vehicle nowadays, it is, we can say, in the space also, spacecraft, aircraft, moreover in the surface vessel. So it have diversified application also. Based on the application, the technology can differ. And auxiliary subsystem, it is as usual, it is mainly the comfort power steering, internal power supply only. So basic component or related technology in an electric vehicle function wise, here shortly briefly I am highlighting. Electric controller here mainly associated to control semiconductor converters. So there are different type control can be designed through the embedded system. This control triple BF, variable voltage, variable frequency control, field oriental control, movable and rotatable control. So in this way, stability time control, vehicle stability control, in this way different type control based on the vehicle or its performance, it can be used. And obviously, as semiconductor converter are using, it controlling will be always from the digital logic or from digital platform using microprocessor, DSP or FPGA. And for power converter, our semiconductor switches like IGBT, MOSFET, these are using. Moreover, here motor is an important choice. because it is mainly propel the vehicle. So there are different type motors also. So appropriate one have to be chosen. So this selection of the motor or drive for electric vehicle depend on many factors. Technology side also means whether its torque speed characteristics are supporting required for the electric vehicle, or cost wise also, moreover vehicle size wise also, whether light vehicle or heavy vehicle, depending on this have to be or cleverly to be selected. And type wise means technological or architectural point of view. Type wise electric vehicle we can classify in different ways, like traditional battery electric vehicle, hybrid electric vehicle, fueled electric vehicle, vehicle supplied by power lines, solar powered vehicle, and moreover electric vehicle supported with the flywheel and supercapacitor. So first one, whatever battery driven electric vehicle. So this one generally whenever we had electric vehicle, we think always this one, there will be a battery and electric motor. Battery will supply the electric motor and then electric motor will drive the vehicle. So main part is battery, electric motor and controller. And here actually electric motor, it can be used in regenerative mode, and in regenerative mode, it can feed power to battery also. So depending on the control and flexibility in of the control in the mode, it can be classified to quadrant control and fourth quadrant control vehicle also. A fourth quadrant means forward and backward motion can be controlled in motor mode as well as generator mode. And two quadrant means only forward and backward in the motor mode. And hybrid electric vehicle, here actually hybrid means here is IC engine also can be with the electric motor, and the IC engine and electric motor, they can be in series or in parallel. If it is in series, like here shown, mainly the electric motor, it is mainly directly connected to the mechanical transmission, but sometime whenever battery discharge gone down, at that time IC engine can be start to charge the battery only. So IC engine here not directly connected to the mechanical transmission. And another hybrid vehicle, this is the known as parallel hybrid vehicle. Here actually mechanical transmission is connected both IC engine and electric motor. So flexibility is here is high. From anyone it can be driven, but here cost is very high. And here fueled electric vehicle, this one indicate electric vehicle driven by the fuel cell. Actually, if we consider why electric vehicle not became not that much popular, or what is the challenges of the electric vehicle, battery is the main thing. We know battery not reliable as our petrol, etc. And moreover, cost of the battery also high. So among the different batteries or other alternatives of the petrol engine, only fuel cell can give the reliability near the our IC engine. And in fuel cell, mainly input is the hydrogen. This hydrogen can be used on board also through cylinder or storage, or it can be generated on board also. So through fuel cell, so reliably this electric vehicle may be run. And new type cell also has come. This is the metal air batteries. So this is also we can say chargeable. And here main technology is replacing the electrodes. So electrodes can be recycled. So this is the electric vehicle using supply lines. So this is not new. So previously, in fact, in Calcutta also, some terms also available. So meantime, actually, we not given attention on this because of extra cost about the overhead line or track, etc. Moreover, sometimes this become the obstacle of the public transport, etc. But considering the these pollution things, again, it can be useful. And here solar powered vehicles, this one indicate actually it is fully powered from the solar energy. Obviously, special type, mainly monocrystalline solar cell to be used where efficiency is high. Moreover, it can be used in sunny region only, where solar irradiation is very healthy. And some model or prototype already it is demonstrated from different company. Then electric vehicle using flywheel and supercapacitor. Actually, supercapacitor and flywheel, they can be used with our conventional battery sources to increase the reliability. Actually, flywheel and supercapacitor, what happened? Their power density is high, but their energy density is very low. So if power density is high, what happens? Whenever high torque required, suppose uphill driving, at that time, extra current can supply this, but it cannot support long time. So that is why using flywheel and supercapacitor, this type high power devices with our lithium ion battery sort of thing, reliability can be increased. And another thing in regenerative power also, while downhill driving easily can be stored in these devices. So electric machines means electric drives. Obviously, if we see the electric machine, there are a lot of machines, and we are already using also. There are AC, DC machines, but which one is suitable for the electric vehicle? This one to be selected, considering many criteria. Actually, every machine has its pros and cons both. So depending on application and moreover, considering the cost, we have to select. So here I am considering mainly 4 type motors: DC motor, AC induction motor, BLDC motor, another is switch reluctance motor. And our normal DC motor, obviously, its technology is very mature, and moreover, cost-wise, it is a low-cost one, and its reliability also high. But only one side is drawback: it is bulky, and another always their maintenance required because of mechanical commutation and brushes. Because of parking in commutator and brushes also, high speed cannot be achieved. This is another drawback in using the electric vehicle. And induction motor means AC motor, generally we consider the most favorable one, or compared to DC motor, we favor AC motor. So AC motor advantage is there is no sparking, that is why it can be used in hostile environment also. Moreover, each size for same rating, each size is less compared to the DC motor. But in this AC motor also some drawback, like efficiency is less compared to some advanced type motor like brushless DC motor or switch reluctance motor, because there is rotor circuit also in induction motor. Rotor circuit also, if splitting induction motor in the rotor winding, or is squirrel cage induction motor in the bar, squirrel cage bar, there will be there is copper loss. That is why efficiency is less. And BLDC motor now is famous because it is widely using in electric vehicles. Though it is burst-less, that is why no problem from commutation or parking. Actually, this, though we are telling a DC motor, actually it is AC. It requires pulsating or changing pulses in winding, free winding. And operation wise, it is like AC motor. And in BLDC motor, main rotating part is the permanent magnet. So we are giving through converter rotating pulse in 3 phase in the stator, and we are changing the poles, and according to this, the permanent magnet pole are changing. And here always require one position, means rotor position sensor, because at the beginning, if there is magnetic locking between the stator pole and the permanent magnet, then starting not possible. So that is why always one sensor, generally whole sensor sort of thing is used to sense the rotor position, and accordingly pulse to be given in the stator winding. And main advantage of BLDC motor, here actually wide range of speed possible. By changing the conduction angle or conduction angle control, speed can be varied. But it also have some drawbacks, like using the permanent magnet. So permanent magnet is costly. Moreover, it cannot be designed for the high torque or large vehicle. So another alternative is the Swiss reluctance motor. Swiss reluctance motor also, it is AC motor, and what happened here actually in the rotor, magnet not required. It is work on the principle of variable reluctance. In stator winding, actually the supply is changing, and that is why reluctance value are changing. Accordingly, rotor always rotate to align in the lowest reluctance. So main advantage here is no permanent magnet. If permanent magnet, there is another drawback is temperature problem. If temperature increases, then also permanent degrade. So from that side also, this SRM motor have the advantage, but it suffer from the torque repel and acoustic noise from this. So if we consider all type motors from AC to DC types or special drives, obviously all motors have some advantage and disadvantage. So we have to select based on the application and budget. So here I am showing a typical picture based on 4 criteria: efficiency, weight, cost, and mainly 3: efficiency, weight, and cost. So here the weight pipe indicate is good, and low weight indicate the inferior quality. So if we see the DC motor, we see cost wise it is good, preferable compared to other, but efficiency and weight wise it is not preferable that much. And induction motor, it is all getting 4. So that means it is balanced from all sides, efficiency, weight, and cost side also. And if we consider permanent magnet BLDC motor, we see efficiency wise it is highest, and weight wise also it is okay, but cost wise it is not that much preferable. Cost would be high. So another special drives, Swiss reluctance motor, here also we are saying efficiency and weight wise it is preferable. So that means permanent magnet BLDC motor and switch reluctance motor, they are competitive. Generally, for the light electric vehicle, nowadays it is preferable. So from these two to be select. And here some control aspect of the BLDC motor. So here just what happened here, as it is a electric drives using to control mechanical aspect. So speed torque characteristics or controlling the torque and speed is the main issue. So what happened based on the commanded torque, means this one depend on the driver input. So the brake reference current will be calculated, then it will be adjusted to the converter. So speed control also possible. Here simple speed control philosophy also given for the BLDC motor. So I am not going in depth. Just here another I am showing here one charging and power supply technique. Here this is the main battery of the electric vehicle, and here we are considering from outside source, maybe AC source, AC lines, it can be charged, and here is the motor, maybe BLDC motor, and from battery through this converter, AC pulse will be given in the stator winding of the BLDC motor. So ultimately what happened, this battery sometimes have to supply the power to the motor, and at the time of charging, battery have to take the power from outside line. And another option, taking power from the motor at the time of regenerative mode of operation. So in this condition, this circuit can be used. So first one, PPS discharging mode, this one indicate main battery driving the motor. So in this case, what happened, S1, switch S1 will be on, and S2 and S2 will be always off, and S4 will be turned on off periodically. Then power will go from battery to this traction motor. And another case here, PPS charging. PPS charging in two conditions, one from the line, power line, maybe in the standstill condition. So at that time, this DC bus voltage will be rated below, for example, 48 volt. So at that time, boosting not required. Directly, power can be given to the battery for the charging purpose. So at that time, S1, S2, S4 will be turned off, only S3 to be on off periodically. And another option, whenever battery will be charged from the regenerative power. At the time of regenerative power, what happened? The terminal voltage will be low because it will be supplied from the BLDC motor. So here, actually, this converter to be used as a boost converter. So at that time, S1, S4 will be off, and S3 on, completely on, only S2. It will be off on periodically. Then it will work like a boost converter. So in this way, charging, discharging, everything is possible. So it is like a basic control circuit of an electric vehicle having the onboard battery and charging facility. So it is the some commercially available electric vehicle. So it is a specification of a typical electric vehicle. I am not here is a charging option. Actually, different way can be charged. And briefly, I am telling charging can be categorized level 1, level 2, and level 3. Level 3 means fast charging. Level 1, it is low voltage DC and overnight time, 8 to 9 hours required. Level 2, it is moderate time required. Generally 1 hour can charge for 12 to 54 miles. And level 3, at this is known as fast DC charging. This one can charge within 15 to 30 minutes, 80% of the vehicle. And recently, some national mission also added with previously 8. So one is mainly to increase the infrastructure toward the charging, and another national mission, National Electric Mobility Mission Plan 2020. This one mainly to marketize or to promote a hybrid and electric vehicles in the market. So finally, in conclusion, obviously, so nowadays electric vehicle is considered as a promising alternative to replace IC engine-based vehicle. Actually, electric vehicle will not consume less energy. Thing is that electric vehicle transfer the source. It can take different renewable energy sources also input. It is that thing. And pollution aspect also, it cannot be comment that electric vehicle will decrease the pollution, because battery technology also important aspect. Let it is battery, etc. They are waste to be managed properly. Then only it can save the environment. Otherwise, waste from this type battery, it can degrade the environment also. So thank you.
Thank you very much, sir,
Yeah.
for your nice presentation on electric vehicle and motor drives. You have nicely pointed out the different types of drives and electric vehicle, and what are the different charging options available, and what are the various other companies who are running the electric vehicles in India. Thank you very much for your nice presentation, sir. Thank you. May I now request the next speaker, Dr. Tirthraj Sen, FIE, Principal Women's Polytechnic, to deliver his lecture on magnetic circuit calculation for design of electrical machine. Dr. Asim sir, can you kindly screen sharing?
Yeah, just
So we are going for the next presentation, so you have to kindly switch off this one.
Yeah. So leave now. Yes. No problem.
Hello. Good evening to all. First of all, it is my privilege to be here to present in this occasion of 32nd Foundation Day of Institution Engineers And today is the fourth day. And the fourth day is one-day seminar on power converters and drives for electrical vehicles. So first of all, this I want to convey one thing, that is this presentation is made only specially for the students of undergraduate, postgraduate and MTech and maybe some research scholars. So I think some of the students are present here. Any students from BTech level here? How many students from BTech? BTech? Any students from MTech level? Okay. Research scholars? Any? Okay, thank you. So while we design for a thing for a designing of electrical machines, there's a vast subjects and there are different chapters, different topics. But one thing we have to take over, that is the magnetic circuit calculations for designing of electrical machines. So magnetic circuit means actually the flux which is confined in different areas of electrical machines. And this is a main parameter by which the electrical machines will be operative or maybe made operative. And this flux is created by some windings along with some voltage, and current may be passes out from these windings, and thereby a flux is created. But this is very much difficult to calculate all the flux. But for design consideration of electrical machines, or maybe it is, however it is in rotating electrical machines, maybe static machines, this flux, or especially our reluctance of flux, permeance calculations in the air gap is very much important. Otherwise, we cannot design it properly. So, first of all, if we think about electrical machine design, so the designer should be familiar with the some national and international standards. Number one is Indian standards, which is called IS, Bureau of Indian Standard, BIS, Indian British Standards, England International Electrotechnical Commission, NEMA, which is the National Electrical Association, and specifications. Specifications means depends upon our requirement of electrical machines, maybe a static machine, maybe rotating electrical machines, and that requirement is coming out from the consumer, maybe industrial consumer, maybe a domestic consumer, maybe other consumer, and cost of material and labor. So if think about the cost of material also while designing electrical machines, this is a very much important factor. And the manufacturing constants. There are some constants while we manufacturing some parts of the electrical machines in the factory. So that all are must be considered for designing electrical machines. For magnetic flux, if we consider a magnetic flux, this is a very much important parameter for designing of electrical machines. And this flux plays an important role in converting and transferring the energy for generators, motors, and transformers. The field or magnetizing winding. Why it is called magnetizing winding? Because this field is created by some wounds. That means some conducting wire will be wound in a magnetic material, and that particular coil may be a iron core, maybe a air core. So depends upon the requirement of flux in rotating electrical machines. We have to calculate first what is the requirement. Then depends upon the rating of the machines, we should consider how much flux will passes from the different area of the electrical machines. As far as our rotating electrical machines, we know very well that is there is a stator part and a rotor part, and stator also carries some windings and rotor also carries some windings. Maybe in case of induction motor, the rotor may be a long bars. But whatever may be the different parts, the transfer of energy is very much important for electrical machines. So the air gap is very much important factor for rotating electrical machines. And to calculation of air gap, calculation of flux, which is passing from stator to rotor and maybe rotor to stator, vice versa, is very much important factor. So the field or magnetizing winding of rotating machines produces the flux, while armature winding supplies either electrical power or mechanical power. Because this fluxes is very much important, because with this flux some energy is developed in the stator or maybe rotor, and after the flux a mechanical energy is developed. It is called mechanical power equivalent to electrical power. Suppose a DC generator, you know very well, DC motor, EB into IA, this is a mechanical power equivalent to electrical power. EB means back EMF and IA is the armature current. So that's why like that. So in case of transformer, primary winding, you know very well, primary winding supplies the power demand of the secondary. While as we rather it called, maybe it is secondary to primary or primary to secondary. Whatever maybe you connect the input power, one part is input, another part is input, output. And the basic design of electrical machines involve the dimensioning the magnetic circuit, very important factor, then electrical circuit, then insulation system, and carried out by applying analytical equation. So analytical equation is depends upon the design. There are different equations that are very much helpful for design. But before we go through the analytical equations, first we have to think about the magnetic circuit. How the magnetic circuit we develop and how the fluxes are rotating or maybe utilized. Full utilization of the magnetic flux is very much important factor for designing of rotating electrical machines. Whenever we think a design of any electrical machines, number of problems a designer is generally confronted, for which there may not be one solution, but many solutions. But we think about our solutions depends upon our requirement, maybe industrial requirement, maybe domestic requirements. So design should ensure that products perform in accordance with the requirement of higher efficiency. This is a very much important factor or important condition for electrical machine design, because our efficiency should be higher. Then lower weight of material for the desired output. So our weight of the machine also very much less. Our requirement is weight of the material. So we design in such a way that is our space should be fully utilized, because there are different types of windings you are utilizing in electrical machines. Suppose copper windings, maybe your aluminum winding, because it is not possible for us to utilize gold or platinum, because it is not possible for us. So we are utilizing copper and aluminum. And lower temperature rise and lower cost is also a problems which think by the designer, because temperature should be lower. That means rating of the machine should be lower. And losses very low. And last one is they are very reliable and durable. This is the main desirable properties, the number of problems a designer should think. And for design considerations, there are some common area we should think about, some insulations. And that insulation property, we know very well there is insulation coordination. And that insulation means type of insulator, because this insulation is very much required to ensure the trouble-free separation of machine parts operating at different potential and confined current in prescribed path. So while the insulation is not proper and properly fitted, or maybe the insulation is up to the mark as per the current carrying capacity of the conductor, so there may be leakage current. And leakage current mean high heat will be generated as well as high loss we observe. Then cooling system and or ventilation that ensure the machine operates at specified temperature. That means the temperature specified by the designer, that temperature should be maintained. Otherwise, if the machine temperature crosses the limit, then there may be high loss. And maybe in such cases, the machine will not operate successfully. Then machine parts should be robust. Previously, we are utilizing the DC motors. The DC motors are not robust. Different parts should be changed after periodic time. The art of successful design lies not only the revolving conflict for space between iron, copper, insulation, and coolant, but also in optimization of cost of manufacturing and operating and maintenance charges. Maintenance is a very much important criteria for designing of electrical machines. There are different types of maintenance: preventive maintenance, productive maintenance, predictive maintenance, but maintenance should be avoided. We should design in such a way that the part should be robust, and that involves less maintenance time while the machine will be operated successfully in a long run. The major consideration in electrical machine design, that means the basic components of all electromagnetic apparatus are field and armature winding, because in case of rotating electrical machines, that particular field and armature winding will be separated by dielectric or insulation, and also the cooling system and mechanical parts. Cooling system is very much important parts, because in our industrial applications, big motors, suppose in a small motors or small electrical appliances, the cooling is air cooling only, or maybe forced drop cooling. But in case of the rating of the machine is very, very high, very big motors, industrial motors, then particular winding for cooling operation, we required some hydrogen cooling or maybe very high forced drops cooling by air. And then magnetic circuit of the flux path should establish required amount of flux using minimum MMF. So MMF means magnetic force. How the MMF will be created in windings? Just you give a current. So by current or maybe voltage, a current passes through the winding, then a flux is generated, and that flux will be created some magnetic force. And while the fluxes is created by the magnetic force, or maybe the winding, or it is, in other words, it is called magnetizing force, then the core losses should be less at the same time. Because while core losses will be high, there are different reasons. That means the magnetic material should be very, very soft magnetic material. It is not hard magnetic material. Because we know very well, while the material is hard magnetic material, then what happened? We know very well the BS curve. So BS curve means the BS curve is the reversal of magnetization curve. When motor is rotated, a curve is created. That means the area under the curve is called hysteresis curve, and the loss will be calculated by the hysteresis. It is called hysteresis loss, and that is very much important in case of consideration for designing of electrical machines. So the core should be less. So meaning is that core loss, the core should be have a property of very, very high permeance area and less reluctant area. I am coming out one by one. Then electric circuit or winding should ensure required MMF induce with no complexity in winding arrangement. That means winding should be properly fitted with the parts, and where the copper losses should be less. Limitation in design. The material used for machine and others such as cooling, etc., imposes a limitation in design. the limitation stem from saturation of iron, current density, conductors, temperature, insulation, mechanical properties, efficiency, power factor. Now, first one is very much important, saturation of iron parts. We know very well what is saturation. Just you think about the saturated solution. So while some fluxes are entered in the intermolecular area of the magnetic material, after some time, whatever may be the current or flux is increased by the MMF or maybe magnetizing force. After some time, the fluxes are not entered in a particular area of the magnetic material. That is the saturation region. And after the saturation, you see in case of DC generator also, if you study the DC generator, the open circuit characteristic of DC generator, you see after some time, the voltage is very much fixed at some level because the saturation is done. So in here also for designing electrical machines, the saturation of iron and current density, what is current density? Current passing per unit area, and the conductors, temperature is very much important factor, limitation of design. Insulations, again I told you, mechanical properties, efficiency, power factor. So these are the limitation of design. So we have to think about all of the factors while designing electrical machines. Now saturation, for saturation, higher flux density reduces the volume of iron but drives the iron to operate beyond knee of the magnetization curve or in the region of saturation. That means magnetization curve, it is called BS curve. Flux density versus AT, it is called AT. AT means ampere turns. Whenever we wound some windings, how much turns will be there with some current flowing through the winding, that is called AT. So that AT is considered as a H, and that H is called magnetizing force. And that magnetizing force will create some flux, and that flux will be utilized for our energy transfer in rotating electrical machines and also in static machines. So higher flux density reduces the volume of iron but drives the iron to operate beyond the knee of the magnetization curve I am showing you, or in the region of saturation. Saturation of iron poses a limitation on account of increased core loss and excessive excitation required to establish a desired value of flux. So whenever there is no saturation, what happens? That means more fluxes is required by the iron area. So that to minimize, to overcome this flux, then more MMF will be required. That means more energy is washed to create the magnetizing force. So that's why our main aim to get the maximum efficiency of electrical machines is not reached. So it is also introduced harmonics. So you know it is a BS curve, flux density versus magnetization curve, and you see this area, well, whenever there is a magnetizing force, and while the flux is created by the magnetizing or maybe windings, then what happened? The saturation point will be reached after some moment. The saturation of magnetization is reached in a particular point. That means if F is the saturation started point and end point is the A. A means in this point the saturation of region or maybe magnetization is reached. And after that, if we close the circuit, open the circuit of the magnetization curve or maybe that particular winding which leads to generate flux, then the magnetization, that means magnetizing force will be comes into this way, not it is follow the this way, and after some time after this it will reach in the B curve, and particular this area is called retentivity. Now if the voltage will be just reversed or the current direction will be reversed, then after some time our magnetization of the particular magnetic material will be completely zero. So up to D to, it is C. B to C, the C is called coercivity, and the field by which a magnetic material is completely demagnetized by the flux, it is called coercive field, and this point will be called coercivity. And again, if again we passes some current in the negative direction, then it is seen that is the magnetization again it is developed in the negative region. So this saturation is done in the opposite direction. Again, you reverse the direction of magnetization, then again see, again this curve will not follow the original path. Again, this is are going towards the another path. This is also very much reason for that. And it is depends upon the magnetic material. Magnetic material mean you know very well, our electrical machine design, the magnetic material, there are three types of magnetic material we are utilizing. One is ferromagnetic material, ferro, and diamagnetic material. Diamagnetic material means which is not passes any flux. Meissner effect of superconductors you know very well. That means fluxes are just diverted. They are not entered in the region. That means the magnetic moments are create the opposite direction, while flux will just try to enter in the metal. So all conductive materials is a diamagnetic material. But other than diamagnetic material, then another stage it is called paramagnetic part. So while temperature will be increased, so that temperature, why temperature will be very much important for designing electrical machines, because whenever due to some fault of the designer or maybe any short circuit or maybe bad insulation, when the temperature will be increases, what happens? Then that particular magnetic material which is utilizes in particular machines will be just into change into paramagnetic material. But our attention is not that. We design in such a way that particular temperature will be maintained by the electrical machines, and also that particular magnetic material will be sustained in a particular area. That means it is ferromagnetic area, not paramagnetic, not diamagnetic. So there is another some limitation in design: current density, insulation, high efficiency, and high power factor, mechanical competition. All are known to all. Current density means higher current density reduces the volume of copper but increases the losses in temperature, because current passing per unit area, it is very much important for designing rotating electric machines. Insulation already I am told. High efficiency and high power factor is also possess limitation, and a low value of efficiency and power factor on the other hand results in very high maintenance cost. Because whenever efficiency will be less, that means some problem will be occurred in the electrical machines. So our maintenance cost is high, as well as our costing of the machines to operate is very much high. Basic material, basic conducting material we are utilizing in electrical machines or maybe electrical devices is copper and aluminum. If we go through the particulars of different particulars, or maybe rather than it is called some parameters of the copper and aluminum: resistivity, conductivity, density, temperature, coefficient, efficient of linear expansion, tensile strength, mechanical property, melting point, etc. You see the resistivity of copper at 20 degree, it will be 0.0172 ohm per meter per millimeter square. But while in aluminum you see it is resistivity is very much greater than the copper. And conductivity you see 20 degree, conductivity is very much high for copper and aluminum is less. Same temperature. And if you see the tensile strength of copper is very much more than the aluminum. So aluminum is a lightweight and copper is a very high weight. So same 1 kilo of aluminum, if you just utilizing for electrical machines, it will require more space for the electrical machines. But while we using copper is also high tensile strength, and also electrical conductivity is very much high, as well as the tensile strength, as well as the volume of copper. The same volume of copper is taking less space than aluminum while utilizing the rotating electrical machines design. So this is a comparative study of the copper and aluminum as a conductive material. Then if we go to the magnetic circuit calculations and we think some parameters of the magnetic circuit, we know flux is the magnetic flux in Weber, A is the magnetic path in meter square, L is the length of the magnetic path, B is the flux density. Flux density means flux plus passing per unit area. H mean again magnetizing force, or maybe it is intensity of magnetization. AT means ampere turn. That means some turns, you can create a turn by wound some coil and you giving some current in the particular coil, then a magnetizing force will be developed, and that force will be utilizing for our electrical machines for transferring energy. This is the main thing you have to understand. And AT is total MMF. Mu zero, mu is, you know very well, permeability, because flux will the permission of flux in different area is not same. For air, it is value same one, but if you go through oil or maybe water or maybe another parts or maybe iron, the different values we are showing for permeability. So mu is the absolute permeability, and which is divided into mu zero, mu r. Mu zero is the absolute permeability, and which is 4 pi 10 to the minus 7. Already you know very well. And mu r is the relative permeability, and it depends upon the area where the fluxes will go through or passes through the particular medium. And S is the reluctance, which is analogous to resistance of electrical circuit. So in our magnetic circuit calculations, we have to calculate the reluctance of air gap in a particular machines and also a permeance calculation. So this is the basic difference between electrical and magnetic circuit, because electric circuit, you know, Ohm's law express relationship between EMF, current and resistance, V equal to IR, you know. Magnetic circuit, it will deals with the flux, MMF and reluctance. So analogous flux means it is current, and analogous to MMF, it is EMF, electromotive force, and analogous to reluctance means it is the resistance. So if we consider the whatever called the flux, that means current, so, or maybe in magnetic circuit, it will be ampere turn by reluctance. So ampere turn by reluctance means phi equal to I equal to V by R. So it is a V, and R is the reluctance, analogous to electric circuit. So 80 into permeance. This symbol is called permeance, just like your conductance in electrical circuit. So conductance means, what is the definition of conductance? Which permits the current to passes through the winding, and resistance means which obstruct the current direction in electric circuit. So same thing is happen. So another formula, we have to reluctance equal to length per area and 1 by permeability. That means L by A mu. So what is L? L is the length of the magnetic path. If length will be divided in different parts, then it will be L1, L2, L3, L3 like that. And capital L is the total L1 plus L2 plus L3 plus L4. And area is the area of the particular magnetic path. And mu is the absolute permeability. Now also it is electrical and magnetic circuit comparison, you know. It is bypass. So magnetic material already, I'm telling that is different types of magnetic material which are very much important for designing of electrical machines. But what are the main properties of magnetic material? Number one, low reluctance or should be highly permeable. So reluctance means which is analogous to resistance. What is meant by reluctance? Which opposes the flow flux. And permeance means which permits the flow flux in iron area. So just like it, your conductance. And high saturation induction to minimize the weight and volume, because if saturation is not high, saturation means that particular magnetic material will be very, very soft magnetic material. That means BS curve will be very, very narrow. Otherwise, your losses will be very, very high. If losses will be very, very high to same value of saturation, you have to utilize more windings and more power to saturation purpose. That means, amar jodi at a winding, suppose at a winding ache, one winding, that winding will create some ampere turns. That ampere turns is not up to the marks for saturation of magnetization. So while saturation and magnetization is not there, so after saturation, the current or my windings will be come in contact with the flux. Because you know saturated solution means whatever unless the saturation will be saturated, then it will be dissolved. A sugar or maybe salt is dissolved in water. Whenever we observe that it is saturated solution, that means after adding some sugar and or maybe your salt, it is not dissolved in water after some time. But there is another condition is that whenever your temperature increases, when temperature increases, then you see then some value will be again dissolved. Some amount of salt and sugar will be dissolved in the water. So temperature is the main criteria. So here also for designing of electrical machines, if temperature will be high, then your losses will be high because your insulation failure will be there. So why temperature will be high? Because when it is the second condition, high saturation induction. Because when saturation will be very, very high, then the weight of the volume of the iron parts is related to the design of the electrical machines. Then narrow hysteresis loss loop or low coercivity, already I have told. A high Curie point means a point where due to heat, the magnetization is completely destroyed. It is called Curie point. So a high Curie point, above Curie point or temperature, the material loses the magnetic property or become paramagnetic, that is effectively non-magnetic. So you know very well, a machine is operated in a particular desirable temperature. When the heat is increased, then what happens? If it is not up to the mark, then problems with the machines we observe, that is design is not up to the mark as per the requirement of the design. So should have very high energy product. So this is the actually figure of a flux path in various electrical machines. First one is the coat type transformer and shell type transformer, you know very well. That is the flux path in rotating. In case of coat type transformer, it is one path, but while you go through the shell type transformer, as there are two windows, this is called window of the transformer in the core. So there are two parts. The fluxes are rotating, and one flux just link with the other winding and create some energy, and that energy will be utilized for our purpose. And this is the DC machines. It is obviously salient pole DC machines, and you see this is the main area where the fluxes are coming from stator to rotor. So stator means it is a salient pole stator. Some poles are there. That poles are created some flux, these poles. So this flux will be utilized totally. How it is totally utilized depends upon the magnetic material and the uniform air gap. So design should be in such a way the air gap should be uniform. So while we try to calculate that H equal to F into S, that means flux into reluctance. So it comes out phi into 1 by L into 1 by previous equation, 1 L by A mu. So phi by A, and we just separate, we arrange this equation in such a way that is it is phi by A, 1 by mu. So phi by A means B, flux density, and 1 by mu. So B equal to mu 0 H. Already is a renowned equation for designing electrical machines. In case of material length L and carrying uniform current or flux, the total AT, MMF is equal to H into L, and it is called AT into L. So H means the total magnetizing force it is created for electrical machines, and AT equal to L. Time is over. Actually, so just 5 minutes I'm taking, just only 5 minutes. So actually for the magnetic circuit calculation, this is a very much important. MMF for air gap. Already I'm taken, the air gap is very much important portion of the electrical machine for designing of electrical machines. So this is the main parameters we have to calculate for electrical machines. And LG is a gap length, Y is in slot pitch. What is slot pitch? Center of one slot to center of other slot. You know pole pitch. So pole pitch means center of one pole to center of other poles. So this is actually the figure how the slot cell there, slot is teeth and the radial ventilating ducts. So our main attention for different to calculate the magnetic reluctance of air gap, one is for smooth armature and one is called slotted armature. So how we calculate the smooth? If we consider this is the slot pitch, that means YS, and this is the air gap of the machines. There are two types of armature in electrical machines. One is called smooth armature and what is called slotted armature. In slotted armature, if we consider WS is the width of slot and WT is the width of tooth, then we have only considered for one slot pitch. So reluctance air gap, just we have to utilize in the previous formula 1 by mu 0 into A. So L means here LG, that is the gap length between stator and rotor. So LG by mu 0 into L into YS. This is a general formula for calculating the reluctance of air gap. And for slotted armature, you see the effective area of flux path is substantially decreased. Why? Because this is the air and this is the iron. So wherever the fluxes are coming from stator to rotor, maximum fluxes are contracted in the tooth area. And there is some fringing effect also. So a effective or contracted slot pitch will be considered as YS dash equal to WT. That means this area will be WT. So it will be YS minus WS. That means the new formula is YS is the slot pitch and WS is the slot width. And reluctance of air gap in a slotted armature will be calculated like that. SG equal to LG by mu S into YS into SL and LG by into L to YS minus W. Just put the value here. And after that, if we consider the fringing effect, what is fringing effect of armature? That means some fluxes are try to enter in the edges of the tooth because tooth is an iron area. That means it is a low reluctant area. So some fluxes are coming from the tooth and some fluxes are coming from the straight way. So fringing of flux for teeth edges in a slotted armature it is shown in figure. And also you see due to fringing of flux, we should calculate very prominently what is the reluctance of air gap by utilizing the previous formula. So a simple method adopted for calculate the air gap of flux is that by assuming the air gap is flux is uniformly distributed over the whole slot pitch except for a fraction of slot width, and the effective and contracted slot pitch is YS dash. This is the YS dash, and that YS dash will be contracted. That is, if you consider the fringing of flux, that edges of flux which are try to enter in the edge area of the tooth. So YS equal to WT plus delta into WS. Delta is a factor, and if you arrange this fashion in this equation, it is coming out YS minus 1 minus delta into WS. That means WT plus delta into WS. So WT plus WS again delta into WS minus WS. So this will be cancelled. So again the equation will be written like this. And this 1 minus delta factor is called KCS. Very much important factor for designing of electrical machines. And this KCS is called Carter's gap coefficient, which is meaning slot opening by gap length. That means what is the slot area? What is the opening area of the slot? And gap length means what is the air gap length? So in this way, you can calculate the fringing of flux under consideration, and the contracted slot pitch you can also consider for calculation of reluctance of air gap. So time is very limit. So I have another slot of some slides. So thank you very much for giving me the opportunity. Thank you all.
Thank you very much, sir, for your wonderful presentation. I hope due to the shortage of time, sir could not utilize all the slides for us. We hope to see next time. Thank you very much, sir. Now, if there is any question, you can put forward. If there is any question, you can put in the chat box. Though there is one question we can see here. Can you tell about the advantage of 5-phase motor over the other higher phase motors? Hopefully, this is related to the presentation of Ranjan Kumar Vera, sir. So he is presently unavailable with us. He mail ID and other details are there. You can contact him for the answer, or you can clarify your doubts. One more query is I want to do research work in multi-level, multi-phase machines. So that is again goes to the same panelist, Dr. Ranjan Kumar Behera. So you can mail him regarding your interest. He may consider or not, totally depends on his considerations. Thank you. May I now request Engineer Subhash Chaudhary, sir, Advisor to the Electrical Engineering Division, IA Tripura State Center, to deliver his valuable speech. See, this question definitely goes to this Dr. Ashim Datta, sir. So on behalf of him, I don't know he's available or not, but on behalf of him, can I reply? So basically, there are basically categories of advanced machines: VLDC, PMSM, and another is SR. So presently, we are mostly working with the VLDC for electric vehicle application, but due to some problems, R&D is now going toward the PMSM works. Okay, so a Swiss reluctance is not advisable as far as my knowledge is concerned, because there you need to sense this eddy currents for controlling of the operation. This is as per my knowledge. Other details you can Google it. Question: with respect to performance. So that may be, but it doesn't mean that based on the performance only we'll consider. There are other parameters we have to go for optimization or compromise between these motors. So as far my knowledge is concerned, the SR we are not going to use for electric vehicle application till now. Okay.
Hello.
Before another application.
Good evening. So, respected Hemant Thakre, President IEI, Shishir Kumar Banerjee, past president, other dignitaries, and other dignitaries at the other end of the webinar session and here in the auditorium itself. And Chinmay Devnath, the president of this center. So initially, we set up with the intention of this center. The main purpose is for cultivation of science and technology for the development of the state and the region as well. So today, I have really enjoyed all the papers and seen that our purpose is fully successful, because the target is to reduce the pollution in the atmosphere by searching some alternative motive power instead of petrol, diesel, etc. So if we go for electric vehicle, pollution will be less, obviously. So 3 types of vehicles are in our site. First is small vehicle that can be run even by solar power or other power. Small power is requirement is there. And medium requirement is bus, public transport. It may have a charging station for fast charging of the charger stored in the battery. And finally, the long vehicle electric train. If I am wrong, please correct me. I am a graduate of 50 years back. Today is 2022, and I passed B. It's 50, 60, 71, 72 batch, final batch. So an electric train, it needs 2 types of power. One is starting power, which is very high power it requires to overcome the momentum inertia. And when it start running, then small power, less power is required. So that power for the train, it is at earlier, I don't know, it was 22 kV transmission. Sorry, now 22 kV transmission, 22 kV motors, and it was 13 to 15 kV electric motors is being made. Now, for at that time, I remember it was a DC series motor having the highest starting torque, and this can be utilized also for running also as well. And in this case, all the 3 subjects has been discussed here. One is high power converter for electric traction, industrial application. This is the high power. And second is, anyway, yes, all the 3 papers has been discussed here. And finally, my thanks to Hysteresis, my dear friend. He has discussed something which I was a student in 3rd year, 4th year, and 5th year. Because in our case, it was 5 years integrated course B. He has repeated everything in 3rd year, 4th year, 5th year so elaborately, so nicely. It gives me the light of those days. I remember. My thanks to you especially, apart from all the expert speakers. So our purpose of setting up this, choosing this subject is fully met. And my thanks to the organizers and the students present, because it will be most helpful for them. I tell you, you go through the book, you will get the knowledge. But if you join in such a discussion and seminar, you will refresh it like anything. You will be forget. And many things I have forgotten because I passed. I said that 50 years back. I remember sometimes late, okay, ये point तो था, बोलना था, ये बोलना था. It happens because of the memory goes down after certain years. I'm 70 years old by now. Anyway, I enjoyed this seminar very much, and my thanks to the organizers also as well. Thank you very much.
Thank you very much, sir, for your lovely words towards your experience and towards your college days experience. And today you have experienced one more class of Pithras, sir. So thank you very much, sir. Now we have to come up to the summing up session. So today we are organizing this one-day seminar on power converters and drives for electric vehicles, organized by the Institution of Engineers India, Tripura State Center. So in this discussion, we are having basically three panelists. One is Dr. Ranjan Kumar Behera, Professor IIT Patna. His topic was utility-friendly power converters for electric traction and industrial application. And where he has rightly pointed the application of the different high power converters, starting from his experience of work in Indian Railway and his experience in USA in the along with Tesla company. So what we come out of this discussion of Ranjan Kumar Behera, sir, that the high power converters are basically very much essential for our applications nowadays for electric tractions and industrial applications. Next presentation was given by Dr. Asim Datta, sir, Associate Professor of Electrical Engineering Department, Rajpur University, on the topic of electric vehicle and motor drives. So he has also given presentation with the advanced machines and how we can consider the selection of the machines based on the performance parameters and what are the converters we are using. So these are having a link with the today's topic of power converter and drives. So the initial portion of converter was taken care of by this Dr. Ranjan Kumar Behera. Next, it comes up with this motor portion, that is the drives of the electric traction, being presented by Asim Datta, sir. And lastly, Dr. Tetra Sensor has nicely presented the basic thing, which is very much essential for this electric vehicle, because the main thing is we have to control the machine. So if there is no proper designing of the machine, it is quite difficult to carry out the proper implementation of the electric vehicle or any other motor drives applications. So these are very interesting. So he has, sir has also nicely mentioned about different standards, including NEMA, which is very much correlate with the motor design applications. The NEMA is the main source which will certify your design. So what actually we are doing here, apart from this, our other distinguished guests like Dr. Hemant Thakreji, President IEI, then Professor Dr. Sudhir Kumar Kalla, Chairman Electrical Engineering Division Board, IEI, and our center Chairman, Engineer Chinmay Devnath, sir, and Dr. Priyanath Das, Chairman of Electrical Engineering Division, then guest presenter, Engineer Vivekananda Rai, sir. All of them has highlighted starting from the journey of IEI Tripura State Center, then how we have maintained during the COVID situation, and what are the various highlights about the different speakers, their biographies, like something like about how their success stories. All these things are being taken care of. Now, if we sum up, we can come to say that this electric vehicle nowadays is all in news because it is going to be very much prominent in the very near future. So most of the countries are nowadays trying to eliminate or move towards electric vehicle by next 3 to 4 decades. Hopefully by 2050 is the target for most of the countries to come up with the electric vehicle. So in the same way, so we'll try to give away some of for these things of power converter and drives for electric vehicles. And in due course of time, we'll submit the recommendations of this, whatever comes out of this seminar. So here we ends up by summing up. Now the next will be vote of thanks will be taken care of by Dr. Subodhi Bhattacharya, Honorary Secretary, IIA Tripura State Center. May I now request Dr. Subodhi Bhattacharya sir to proceed for his vote of thanks.
Good evening to all. I, on behalf of the Institution of Engineers India Tripura State Center, sincerely express our thanks to Engineer Mahananda Deborma, Director General Tripura Renewable Energy Development Agency, who is present here today and graced this seminar program as chief guest in spite of his busy schedule. We also gratitude to Dr. H.O. Thakare, President, the Institution of Engineers India, Engineer Shishir Kumar Banerjee, past President, the Institution of Engineers India, and Professor Dr. Sudhir Kumar Kalla, Chairman, Electrical Engineering Division Board, the Institution of Engineers India, who have graced the program today with their kind presence. We also express gratefulness to Department of Electrical Engineering, National Institute of Technology Agartala, and Tripura Institute of Technology Agartala for their immense support towards organizing this one-day seminar on power converters and drives for electric vehicles. In association with the Institution of Engineers India Tripura State Center. We also sincerely acknowledge the guidance and support received from the Electrical Engineering Division Board of the Institution of Engineers India for this seminar. We are indeed thankful to our distinguished panelist, Dr. Ranjan Kumar Behera, Professor, Department of Electrical Engineering, Indian Institute of Technology, Patna, Dr. Oshim Dotto, Associate Professor, Department of Electrical Engineering, Tezpur University, Dr. Tirtharaj Sen, Principal, Women's Polytechnic, for providing their valuable time for the seminar. We are also obliged to Engineer Chinmoy Devnath, Chairman, the Institution of Engineers India Tripura State Center, and also Chairman of the Organizing Committee of this seminar program, Professor Priyonath Das, Chairman, Electrical Engineering Division of the Institution of Engineers India Tripura State Center, and also Head of the Department of Electrical Engineering, NIT Agartala, Engineer Subhash Chaudhary, Advisor, Electrical Engineering Division of the Institution of Engineers India Tripura State Center, and former Director and Chief Executive Officer, Tripura Renewable Energy Development Agency, Engineer Vivekananda Rai, former Additional General Manager, Tripura State Electricity Corporation Limited, other eminent personalities present either physically or virtually in this one-day seminar on power converters and drives for electric vehicles. Besides, we are also indebted to all dignitaries, senior engineers, council members of the Institution of Engineers India, officials of the Institution of Engineers India headquarters, past chairmen and past honorary secretaries of the Institution of Engineers India Tripura State Center, corporate members of the Institution of Engineers India, participants from various departments, academic institutes, and stakeholders, and each and every member of the organizing committee and office staff of the Institution of Engineers India Tripura State Center, Gautam, Tamal, Omit, whose active involvement and contributions have made it possible to organize this program. We also convey our special thanks to Sudeep Chakraborty, Assistant Director of the Institution of Engineers India headquarters, for his valuable support for organizing this seminar program. I also express my sincere thanks to Dr. Vikram Das, Assistant Professor, Department of Electrical Engineering, National Institute of Technology, Agartala, who has given his precious time for this seminar as moderator. I also convey my sincere thanks to Dr. Suman Dev, Convener, Computer Science and Engineering and Electronics Communication Engineering Division of the Institution of Engineers India Tripura State Center, who has made necessary arrangement for live streaming of the program from our center. We are also thankful to the authorities of NIT Agartala, Tripura Institute of Technology, Women's Polytechnic for nomination of the participants. We also convey our thanks to participants who joined this program through online. We also thankful to the authority of the TTADC Polytechnic for nominating the students for attending this program. Last but not the least, we convey our special thanks to Diproditi Rai Borman and Kriti Deepa Rai of Electrical Engineering Department of NIT Agartala for coordinating the program. Further, we beg to be excused for any unintended inconvenience caused during the program. Thank you all once again. Convey our best wishes for Bengali New Year to all. Thank you.
So we are lastly here closing the today's wonder seminar. Thank you very much.
Thank you, sir. So with permission of the chair, I am ending this webinar.